Minions, welcome JEE enthusiasts to this special session of Zero to Hero. Now, it doesn't matter how well you know this topic. If you have the slightest of idea about rotational motion and rigid body dynamics, don't worry guys, by the end of today's class, you're going to be a hero. Now, it doesn't matter whether you're a JEE 2021 aspirant or JEE 2022 aspirant, or whether you are a dropper. This lecture is meant to scale up your learning skills. This lecture, this session is meant to grade you up so that you get confidence in this chapter. And all this with me, Shreyas, your master teacher for physics at Vedantu, and today's lecture is going to be slightly different. It's unlike any of the lectures that I have conducted. What is so different about today's lecture? Well, you will find it out in a bit. But for now, welcome aboard everyone. Hi Vikram, Yalni, Manki, Ankit, Asta, Minyanarthi. Hello Priyal, hello Nancy, hello Jai. Hello everyone, hello Andrew, hello Harsh. Welcome, welcome, welcome. Hello Shravani, hello Anu Peter, hello Likita, hello Velaga. Good evening Uncharted. Yes, we have Monkey Yalni. Yes, I know that. Hello Harshika. Nice to see all of you. Hello Swastika. Hello Marvin. Hello Lekha. Hello Gaurav. Welcome. Good evening. How are you? Yes, I hope you saw the midnight lecture, and I know many of you were also present in yesterday's midnight lecture, and it was like coffee with Shreyas, just like coffee with Karan, and I'm pretty sure you enjoyed it. And in case you have missed it, do not forget to watch it. All right. And this is a brief introduction about me. I'm pretty sure you know, but still you can check it out. And if you want more details, by the way, I have uploaded a very cool reel on Shreyas_Vedantu. It's an amazing reel. Just check it out. How many of you saw that reel just now? I just uploaded it. Well, if you have not seen it, you should definitely check it out. How, the center of gravity is different for men and women. Interesting one. Oh, welcome aboard. Hello Aluru. Hello Vibhuti. Good evening Ruby. Hello. Yes, some of you have seen that. Okay, so now that you're here, do not forget to smash that like button out there. And if you're new, do not forget to hit the subscribe button if you want to become the member of this wonderful, lovely, caring family, JEE Enthuse. And it is free of cost. Go hit the subscribe button because you will get all the important videos, all the important updates, and we will try to make you from zero to hero, be it 11th standard, be it 12th standard, or be it a dropper student. So welcome aboard. Do not forget to subscribe and smash that like button out there. Yes. Okay, and in case you have missed any of these classes out here, like center of mass, if you have missed it, if you are especially 11th or 12th standard student, you should watch it. Modern physics, communication systems, 12th standard students, watch it in case you haven't. Again, for 12th standard students, semiconductor logic gates, if you haven't, watch it. It was conducted yesterday. Collisions was the midnight lecture. Today we are going to do rotation, and this next coming week, we are going to do so many Zero to Hero series. All right. So today is rotation. Then on Monday we have marathon mock test. We have electrostatics, gravitation, Zero to Hero on the next day. Then we have magnetism, EMI, Zero to Hero series, and also sure shot questions for JEE mock test, and also formula revision. Now this formula revision is unlike others. It's going to be a very different kind of formula revision for complete syllabus. Yes, 11th, 12th both. So it's going to be very interesting. Yeah, Ankit, I agree. Logic gates is in computers, and if you have taken computers, it becomes very easy. All right. Okay, Kiruto is here after a long time, I guess. Okay. Hi, Dora Bujia. Nice to see your comment. And I'm pretty sure you are going to give me bujiyas after some time. All right. So let's get going. And yes, Lohit Raj. Yeah, I saw your chats and also your comments out there. Hello, Achitya. Welcome. Oh, monkeys, Kirito. Oh my God. What a disguise. Oh my God. Kirito, what the hell? I mean, like, really? Okay. This was interesting. I was expecting some Japanese character, but okay. I'm not sure what character is this. Okay. And yes, Shiva, I have given my highlighted notes on the Telegram group. Semiconductors, logic gates, everything. So I have given the highlighted notes in the Telegram group. Do check it out there. Okay. Cool. Let's get going then. And it's there in the Telegram group. The link is there in the description box below. Okay, cool. So, I mean, I'm wondering how do you get these names, yeah, querido? I mean, like, really. Glad Asta you love those notes. Yes, those are important pointers. That's it. You read those pointers. Okay. Yes, Jai Bharat. Definitely, all lectures are special. Subhash, don't worry, bacha. Even if your English is not so good, eventually you will learn English. Being here, you will hopefully. Though it is a physics class, slowly you'll also improve your English. And it's very important that you learn in English also, because eventually when you go to college or when you go to a job or anything like that, eventually you have to talk in English only. So it's better you start at an early age. Okay, so let's learn today rotation. Ayman, we are just about to start. Don't worry, bacha, you are not very late. Okay, hello Nike, welcome. Okay. Yes, current electricity, Andrew, we will do it after March attempt, because now I want to do high frequency chapters before the March attempt. For April attempt, definitely I'm going to touch upon current electricity and other topics. Don't worry. Hello Priyanka, join in. Good evening Basanti. Okay, quickly, let's revise the formulas. No problem, Subhash. Doesn't matter even if you're from small town. In fact, my aim is to reach every nook and corner of India. Doesn't matter even if you're from a big city, small city, it doesn't matter. For me, all of you are equal. Okay, don't worry. Okay, even if you type in a wrong statement, or even if you type in a grammatically incorrect statement, nobody is going to make fun of you. It's okay. We are all here to learn, and we are all a lovely minion family. Okay, so it's a process of learning. You will eventually learn. So nobody is going to make fun of anyone. Okay, so let's talk about moment of inertia. So moment of inertia is nothing but, you know, the tendency of a body to resist its change of rotational motion. Just like if you have a mass, when you push it, it resists that change. So more the mass, difficult it is to push it or to change its state. Same way, if something has to be rotated, the difficulty you encounter, the inertia it exerts for changing its state is called as moment of inertia. So different bodies have different moment of inertia, and you are supposed to memorize them. All right. Now today's lecture is not about derivations and all that. It's all about application. We are going to focus more on application because you have limited time. Now if you want in detail lectures of all these things, Flash series is already there on our channel. I have made, I think, 4 to 5 lectures just on rotation. So please, my request is go check them out if you want in detail, because today's lecture is going to be one short marathon. Okay, so it's more focusing on application at the last minute. So ring has mr square, disc has half mr square, hollow cylinder mr square. All right, and hollow cylinder and ring have the same one, solid cylinder half mr square. Okay, standard. Okay, I hope this is clear. Very good. Yes. Now, the thing is, remember, there is a very simple way. See guys, hollow cylinder and ring have the same moment of inertia, these two. And these two have the same moment of inertia, correct? Now, there is a simple property, and that property is, if you have a 2D object, okay, if you have a 2D object and you stretch it, the formula for moment of inertia does not change. I'll repeat. Yes, Vishal, this is enough for JEE. If you have a 2D object and if you stretch it, the formula does not change. Like if you take a ring, visualize it. If you stretch a ring, what will it become? Hollow cylinder, right? So that's why the formula is same. You can see that. That's why the formula is same. Similarly, if you take a disc and if you stretch it, what will it become? It will become a complete volume of a cylinder, correct? So when disc converts into solid cylinder, the formula remains the same. Half mr square. Simple. Is that clear, everyone? Okay, so this is how you are going to remember rings, discs, cylinders. Done. Rings, discs and cylinders are done. Okay, we are going to come to cube and everything also. Okay, don't worry. Hello Anoki, welcome, join in. Next up, for a rod, about the center is what you should remember. It is ml square by 12. A rod about the center is ml square by 12. Now how will you remember it? It comes via practice. How will you remember 12? I mean, like, there is no way, right? You can remember 12 in any other way apart from practicing many problems on it. So solve very basic, very simple problems on finding moment of inertia. Eventually, not at one go, at random times, you will slowly start to remember these formulas. Rod is ml square by 12. And the fact that you are attending this lecture today, it will enter your head even more, because when somebody tells it to you, somebody explains it to you, that's when you realize or by heart it even better. Right angle triangle, this is very important. Right angle triangle, okay, about this axis. When you rotate it about this axis, it is 1/6 mb square, 1/6 mass into base square. Okay, when you rotate a triangle like this, when you rotate a triangle like this. Now, hollow and solid, most of them get confused whether it is 2/5 or 2/3. I'll tell you a simple way of remembering this. Now, 2/3 of any number is almost 66%. Correct, guys? 2/3 is 66%, right? And what is 2/5? How much percentage is it? How much percentage is it? NVD, it's not about its hypotenuse, right? So, yes, Likita, there was a question on moment of inertia, not just in Feb, but also in previous years for a triangle, and many people ended up deriving it. If you remember this formula, it's going to be very simple. 40%, very good. So now, tell me, for a hollow sphere, and if you compare a solid sphere, for whom is the mass going to be closer? For a hollow sphere or for a solid sphere? For a hollow sphere and for a solid sphere, for whom do you think the masses are going to be closer? For solid or for hollow? For solid sphere, right? The masses are going to be closer. So that's why that factor will be less. This is 40%, this is 66%. I hope that makes sense. The closer the masses, the factor will become less. The farther the masses, the factor will become more. Okay, the factor will become more. This factor in a way tells you where is the mass concentrated. So you can think that the hollow sphere, the entire mass is concentrated at 66% of the radius. At 66% of the radius. So that's why understand that, you know, for hollow sphere the masses are far away. For solid sphere the masses are little bit closer by at 40% from the distance. Same way, guys, same way I want you to understand that if I go to the previous slide, for a ring, look at the factor over here is 1, or for a hollow cylinder the factor is 1. That means that percentage wise it is 100%. That means the masses are concentrated on the radius, and which makes sense. The masses are almost thinking of it like that it is concentrated on the radius at 100% of the radius, whereas for a disc or for a solid cylinder it is half. That means it is at 50% from the radius. Think about it, it is at the 50% of the radius. Anish, concentrate beta now, right now. Whatever doubts you have, you put it up in the comment section or ping me on my Instagram handle, which is Shreyas_Vedantu. Alright, either of them, I'll definitely reply. Now let's focus on the class. Now do not spam. Okay, now, okay, concentrate. Okay, so this is 50% for disc and everything. This is 100% of the radius. I hope now it has become little bit simpler for you to understand. Okay, I hope this has become a little bit simpler. Yes, very good, very good, very good. Make notes, Ankit. Excellent, no problem, I know. So this is how I remember the formulas, like for solid and hollow. Okay, solid is closer, so lesser. 2/5 is lesser than 2/3. So that's how I do that. Okay, very good, Fida, very good, Monkey, very good, Shravani. Very good, very good. Okay, now two important theorems. We are also going to see application. First, I'm just brushing up all the theory pointers, guys, right now. So don't worry, slowly I will be also solving problems, and the way I'm going to solve problems today is the surprise. Okay, so the surprise today is the way we are going to solve the problems. Let's see this. Yes, Jaswant, what did I just say? We are going to solve the problems. First, let's brush up through the theory. Don't worry, everything will be done. Okay, Jaswant, don't worry. Okay, Anu, okay, Princey, okay, Astha. All right. Now, parallel axis theorem. When is this theorem applicable? When one of the axes, like you see over here, okay, passes through the center of mass, okay, of the body, and you rotate the body about center of mass. The moment of inertia is ICM. The moment of inertia is ICM. Now, if you choose any other axis which is parallel to this axis, the moment of inertia about that axis, that new axis of rotation, is this value plus m into the shift. H is that shift, the shift in the axis whole square. Alright, so that is the moment of inertia about the parallel axis. Example, imagine you have a rod. Okay, just imagine, guys, you have a rod like this. Okay, and you rotate it about the center of mass. What is the moment of inertia? We just saw it was ml square by 12, correct? About the center of mass. This was the moment of inertia. Now if somebody asks me what is the moment of inertia about this particular axis, what am I going to do? I'm going to use this formula, ICM plus the shift square, m into shift square. So it will be nothing but ml square by 12 plus m into L by, how much is the shift? Look at that, the shift is nothing but L by 2, correct? So L by 2 whole square. So this will become L square by 4. 1 by 12 plus 1 by 4 will become 1/3. So it will become 1 by 3 ml square. So that is why the moment of inertia about a parallel axis from the end of a rod. So when you rotate the rod about the center, it is ml square by 12. But when you rotate the rod about the end, it is ml square by 3. Is that understood? Is that understood, everyone? Is it making sense? I hope this is clear. Yes, Andrew, we are going to do rolling, we are going to do angular momentum, we are going to do torque, we are going to do pulley problems, we are also going to do toppling. It's a marathon session. It's going to extend till 9 o'clock or even beyond. So stay prepared. Like I mentioned in my voice note, come prepared with your snacks and come with a lot of energy. It's going to be a long lecture, but it will make you a hero if you're a zero or anywhere in between. That's what I can tell you. All right, very good, excellent day. Now, this is very important. This is only, very important, only for laminar bodies. Laminar means what? What do you mean by laminar? Laminar means 2D or even 1D objects. Only for 2D or 1D objects you can use this theorem. This theorem is applicable for any kind of body. This is only for disc, ring, rod, plate, triangle, only those kind of bodies, or pentagon, hexagon, these kind of bodies. You cannot use it for cuboid or solid cylinder or solid sphere. You cannot use this theorem. Okay, keep this in mind. And when you use this theorem, what it means, I'll tell you guys. It's very simple. So let's say, for example, this is my H.C. Verma book. Okay, this is my H.C. Verma book from which I give you all the underlined notes of semiconductors, posted it on Telegram. In case you haven't, please check it out. Okay, so if this is one way of rotating this book, this is one way of rotating this book. This is x-axis, correct? This is x-axis, correct? Now, similarly, I can also rotate this book like this. This is y-axis, correct? This is y-axis. I hope this is clear. This is y-axis. There is some inertia. I'm facing some inertia, believe me, to rotate it like this. I'm also facing some inertia like this. Okay, I'm facing some inertia like this. Now, if this is x and if this is y, then this one will be z. Okay, now here, yeah, this is z. Okay, so this one will be z. I hope this is clear. So Ix, moment of inertia about x-axis, plus moment of inertia about y-axis will be moment of inertia about z-axis. Z-axis is perpendicular to the plane. Look at that. It is perpendicular to the plane of the figure. Is that now clear? Yes? Okay. Very good. So Ninad, it's okay, it's your personal choice, but I find H.C. Verma really good. Okay. Clearo? Very good. Excellent, guys. So let's learn a lot today, guys. Today's lecture is going to be very interesting. Excellent, Anu. Okay. Next up on your screen is Newton's second law of motion, torque, and all those things. So let's have a look at that. So angular momentum is also there. Just like you have force is equal to mass into acceleration. Instead of force, you have torque. Instead of mass, you have moment of inertia. And instead of acceleration, you have angular acceleration. So torque is that cause which causes some change in the rotation. For example, your fan is there. It is right now stationary. When you turn on the switch, what is it that causes it to rotate or gain some angular velocity? It changes its state of rotational motion. So that is the torque exerted by the electric motor inside your fan. So the torque causes angular acceleration, and how much will it accelerate will be dependent on the inertia of the fan or that rotating body. So if I apply some torque, some twisting force on somebody, how much will it change its state will depend on the inertia. If it has large inertia, then the acceleration will be less. If it is very difficult for me to rotate it, the acceleration, it will slowly increase its speed. But if the inertia is very low, alright, then alpha will be very large. So it will be very easy for me to rotate it. I hope this is clear. I hope this is clear. Yes, so that's how it works. Now, let me tell you, when you have a fan like this, okay, when you have a fan like this, example, you're looking at it from below. Let's say the motor tries to rotate the fan like this, clockwise. So the torque exerted by the motor will be clockwise or anti-clockwise? Come on guys, let me know. If slowly this fan, alright, gets some speed, angular speed from 2 radians per second to, let's say, for example, 5 radians per second. Alright, if the speed, angular speed increases, if the angular speed increases, so which direction is the torque? Which direction is the torque? Come on guys. Which direction is the torque? Many people are saying anti-clockwise. Why is it saying anti-clockwise? Guys, isn't it clockwise? This is clock, right? This is 12, 1, 2, 6. Isn't this clockwise? Isn't this clockwise? Why are you guys saying? The torque exerted by the motor, to increase its speed. Guys, it will be clockwise. Be careful. Okay? I'm not sure why you said anti-clockwise. So, it's trying to rotate it clockwise. So, the angular speed is increasing. So, the torque by the motor is clockwise. Correct? Correct? Understood? It's clockwise. Okay. Good. Now, after some time, the speed stops increasing. You would have seen that. Obviously, it does not keep on increasing the speed forever, right? After some time, it rotates with constant angular speed. Now, if the angular speed is constant, what will be the value of alpha? Come on, minions, let me know. What is the value of alpha? What is the value of alpha? Think about it. What is the value of the alpha, angular acceleration? Rushi, my name is Shreyas. Very good. Alpha will be 0. So then the torque should be also 0. So if alpha is 0, torque should also be 0. Now what does it mean? It does not mean motor is not applying any torque. Motor is applying torque, but there is one more torque. And who is that torque? That torque is by the air resistance around it. So the motor is applying the torque like this, and the air resistance is opposing that torque. So the net torque is 0. So this torque over here is always the net torque. Keep this in mind. This is always the net torque. Yes. Rushi, alpha is 0 because omega is constant. Alpha is d omega by dt. Remember, rate of change of angular velocity is angular acceleration. So since it was rotating with constant omega, alpha will be 0. So torque, which is net torque, is 0. So motor is applying torque, but it is perfectly balanced by the air resistance torque. I hope this is clear. Very good, very good, very good. Okay, okay. Vasam, just concentrate right now on the lecture. Whatever doubts you have, you can ask it after the class in the comment section, which are not relevant to the subject right now. Let's focus on this. Okay, okay. Clear? Got it, everyone? I hope this was clear. So, initially, when the speed was increasing, which was from 2 radians per second to 5 radians per second, whose torque will be more? When alpha was not 0, when it was increasing its angular speed, and when there was actually some alpha, what do you think? Whose torque was more? Motor's torque was more or air resistance torque was more? Come on, come on. Very good, Kirito. Very good. Yes. Excelente. Uncharted. Very good, Sashi. Motor torque will be more. Eventually, both the torques cancel each other after a long time, and that's why the omega becomes constant. Now, my question to you is, let's say you turn off the electrical switch. Let's say you turn off that electrical switch, then what will happen? The torque of the motor will go away. The torque of the motor will go away. Now, do you see there is only one torque remaining? Whose torque is remaining? Think about it. Whose torque is remaining? Air resistance torque is remaining. Correct? So, if only air resistance torque is remaining once I turn off the electrical switch, so then what will happen? This torque will cause angular acceleration, but in this way, because that torque is in the opposite direction. So, isn't this opposite to the angular velocity? This is velocity, this is acceleration. If velocity is opposite to acceleration, what do you think will happen? Yes, Sashi, correct. Resistive anticlockwise torque. Very good. Yes. Yes, the fan will stop. So that's why if alpha is opposite to omega, it will eventually stop. I hope this is clear. And that will be used as deceleration, or that will be, this acceleration will be called as deceleration. Correct? So when omega is opposite to alpha, it is deceleration. When omega is in the direction of alpha, it is acceleration. Yes, very good, very good. And this will happen until the fan stops. and their air resistance will go away and this velocity will also go away. That's it. Done, done, done. So I hope you have understood the meaning of this equation now. I hope you have understood the meaning of this equation now. Very important equation. So this is net torque is equal to moment of inertia into angular acceleration, and this alpha is nothing but d omega by dt, which is rate of change of angular velocity. True meaning of this equation. Yes, very good. Subhash, don't ask one doubt. Just put up the doubt if it is relevant to this. I will try and answer it. Okay, just ask it off. Don't worry. Okay. Vasam, like I said, most likely the difficulty will be same. And if you have more doubts, put it up after the video. I'll definitely answer it. Okay, very good. Very good, Priyal. Making notes, excellent. Yes, Anokhi, this will be a 2 hours class. If I am taking so much of trouble for you, isn't it your duty to take that much trouble? In fact, that much hard work should be done by you. In fact, more than that, if you want to clear the exam, if teachers at JEE Enthuse and in so many other channels are dedicated for your good, for your betterment, for you guys to score more, you should even struggle harder. Okay, okay. Glad Subhash it got cleared. Very good, Ankit. Thank you so much. Thank you so much. Yes. So now, the next thing, lot of people find it difficult to find the direction of torque. So guys, I'm really planning to make you a hero. So hold on. Now, a lot of people find it difficult. How is the torque, sir? I never get it. How is it? Okay. So let's say there is a point O, and let's say at this point there is a force. Okay, there is a force. Now I want to find the direction of the torque. See, one way is you show this r vector, the position vector, and do r cross f. Now when you do r cross f, you have to use your right hand rule. R is there and f is here, so you can do r cross f. So that way you can get the torque. All right, so the torque will be r cross f. So this torque, like I said, is r cross f. But sometimes it might not be so easy to turn your fingers, correct? Sometimes it is not so easy. So I have a special trick for all of you. Now you might be wondering, what is the special trick? It's very simple. What you need to do, okay, you want to find a torque about this point, right? Take this force and just rotate it about this point. Just try to rotate it about this point. See how is this curve going? Isn't it going isn't it going clockwise? Isn't it going clockwise? That's it. That's the direction of the torque. You can immediately curl your fingers that way. Okay, did not understand? No problem. You will get to know within 2-3 more examples. Imagine one point is here O. Another force is over here. Now if you have to do using r cross f, believe me, it's difficult. What did I say? Take that force around that point where you want to find a torque. So take it around that point like this. How is it going? Isn't it going clockwise? That's it. That's it. The torque is clockwise. As simple as that. Understood? So the torque is clockwise. Very simple. Similarly, I'll give you one more example so that you get it. So let's say this is the point O, and I don't know, maybe the force is here like this. The force is here. Just take it around. Just take it around like this. Just take it around like this. How is it going? Anti-clockwise, right? Isn't it going anti-clockwise? That's it. The torque is anti-clockwise. As simple as that. So cool, Asta. Very good. Done, done, done. That's how it is. Isn't this simple? Isn't this simple? Yes, Aishwarya. Virus alert. So virus alert, guys. Yeah, very good, very good, very good. So this is the simple way of doing it, and that's how. Oops, I think somebody else got. Okay. Okay. Yeah. Okay. So having said this, yes, I would request the admin not to time out our minions. I think by mistake Asta got timed out. So I think he should have timed out a rider. So I would request the admin of our channel to please time out or to block rider. Okay, not Asta. Okay. Okay, cool. Now, once you have understood this, okay, once you have understood this, very good, Ankit, making notes. Now, I want you to focus. Well, for right-handed rule, the torque should be inwards and not clockwise. See, for right-handed rule, if the torque is coming towards you, hold the thumb towards you, the fingers will curl like this. Okay, the fingers will curl like this. And if it is going away from you, then the fingers will curl that way. Alright, the torque will be inwards. As simple as that. As simple as that. Okay, very good. Nia, I'm very good. Yes, welcome to this session. Join in. We are discussing zero to hero of rotation. Now, just like force was rate of change of momentum, same way torque is rate of change of angular momentum. So what is torque? Torque is rate of change of angular momentum, just like force was rate of change of linear momentum. Keep this in mind. So the analogous quantity of momentum in rotation is angular momentum. Now what is angular momentum? Just like torque, you know, L is nothing but, I have just put it over there, L is nothing but R cross P. L is R cross P, L is the angular momentum of a particle. L is angular momentum of a particle. I hope this is clear. Very good. Now, I want you to understand, just like torque, you can also find the direction of angular momentum in a very simple manner. Imagine guys, this is a point and let's say there is a particle of mass m and it is going with some velocity v. Okay, it's going with some velocity v. If you want to find the direction of angular momentum, very simple, again just rotate it about that point O. Just rotate that momentum about that point O. Just see how is it going. Isn't that going anti-clockwise? That's it, it's anti-clockwise. Yeah, okay, I'll tell you, Anu, what does it mean by torque is inverse in a bit. Just give me 1 minute. Yes, don't worry, it's okay, Rushi and Satyapriya, don't worry. All right, so that's how you can find the direction of angular momentum. Very simple guys. Again, if you take one point O here and let's say one momentum P is over here, that's it. Just rotate it like this about it. Just rotate it. You can see again it is anti-clockwise. So it becomes very simple to figure out the direction of angular momentum. Now, if the angular momentum is like this, so if you curl your right hand fingers like this, anti-clockwise, the angular momentum will come towards you. And again, if it is inside, then the angular momentum is clockwise. Now, what does it mean by torque is inside, outside, angular momentum is inside, outside? Sometimes people don't get a feeling of it. Again, we have H.C. Verma to help us. Let's see how to do this. Thank you, Jai Bharat. Guys, listen to this, listen to this. Now I'm rotating this book. Guys, please tell me, how is this book rotating? Please tell me, how is this book rotating? Is it rotating clockwise or anti-clockwise? Please tell me guys, how is this book rotating? Come on, come on, come on, come on, come on. How is this book rotating guys? Yes, anti-clockwise, very good, very good. But I'll tell you what, I'll tell you one surprising fact. For me, it is rotating clockwise. Yes, for me, it is actually rotating clockwise. Don't believe me? Okay, I'll show you. See guys, how was it looking for me? It was looking like this. For me, it was rotating clockwise. Believe it now? I hope it is believable now. So, but for you, if I rotate the same book, it is anti-clockwise. Now, do you see that there is a clear-cut confusion? Clear-cut, yes, point of view, correct. So that means in order to get this ambiguity out of question, we define rotation in terms of right-hand rules. So what do we do? So if it is rotating like this, for example, curl your fingers in the direction of rotation of your right hand. Obviously, everybody has their right hand. Okay, use your right hand and curl your fingers like this. Where is the thumb coming? Towards you, right? Towards you. So now if I say that I am applying a torque towards you, does not mean I am pushing something towards you. No, I am not pushing anything towards you guys. All I am doing is I am holding my right hand, put your thumb towards you, automatically my fingers will curl this way. So there is no ambiguity in that, okay, I am rotating the book this way. Because even if I don't have the book, you just tell me, oh, the torque is this way, right? Okay, just hold your thumb like this, fingers curl like this. Now, if you see from here, it is anti-clockwise, where you see from here, it is clockwise. So there is no doubt then. I hope this is clear. Very good. I hope this is clear. Understood? So this is the meaning of torque being inside and outside. It's just that you have to put your thumb there. Automatically the fingers, curled fingers, show you the sense of application of torque or angular momentum or things like that. I hope that's fine. Very good. Very good. Very good. Excellent. Understood? Excellent, minions. And if you are loving these explanations, do not forget to smash that like button out there. Yes. Yeah. So Ruby, in this case, when I don't know how I was rotating it. So if I was rotating the book like this, guys, is the torque inwards or outwards? Come on. For you guys, is the torque inwards or outwards? Very good, Nancy. Very good. Okay. Okay, Anu, you have changed the device. Okay, I think you are liking from 2 devices then. Okay. Is it outwards or inwards? It is outwards. It is, you can see this. You can see this one. Correct? This one, the left one. If I rotate the book like this. I hope that's clear. Very good. It is coming towards you. This is outwards. Please understand. This is outwards. And this is inwards. Yes, this is outwards. This is inwards. Very good. Very good. Okay. Very good. So this is how you discuss the direction. After this lecture, trust me, you are not going to face any difficulty in directions. Yeah, but you need to practice a little bit. Just don't be dependent on this lecture. I mean, you need to practice this, whatever I told you. Okay. Very good. Excellent. Excellent. Yes. It's just a convention that we use right hand. Somebody would have said, sir, why not left hand? It's a convention. We need a standard, right? Or else there will be a confusion. Oh, these guys are using right hand. These guys are using left hand. So you don't want that confusion. So we decided that we'll use right hand. Very good. Excellent. Now, having said that, yes. Having said that, okay. We were talking about angular momentum. Okay, 1 second. Oops. Yeah, we are talking about angular momentum. Now, is torque and angular momentum dependent on the axis, guys? Please let me know. Is torque and angular momentum dependent on which axis you measure it? Yes or no? Come on, let me know. Is torque and angular momentum dependent on the axis? Think about it. Yes? No? Anu says yes. Rushi says yes. Very good, Ninad. Yes, it depends. Is it possible that a torque measured about an axis is clockwise, but about some other axis is anti-clockwise? Is that possible? Is a torque or angular momentum measured about certain axis clockwise and about certain other axis or somewhere else is anti-clockwise? Is that possible? What do you say? No or yes? Is that possible? Possible, not possible? Yes, no? Come on. No. Some of you are saying no. Some of you are saying yes. Well, let me tell you guys. Look at this. Look at this. Let's say there is a force like this. Let's say I take this point A. Think about it. About point A, is the force producing clockwise or anti-clockwise torque? Think about it. Is this force producing clockwise or anti-clockwise? And if you are confused, just rotate this force, right? Just rotate this force. What is this? This is clockwise. This is clockwise torque, correct? Now, similarly, choose a point B over here. For this point B, what kind of torque or angular momentum will this produce? Think about it. Rotate it like that. Rotate it. What kind of torque is this? Isn't this anti-clockwise? So can you see the same force when measured from 2 different points produces 2 different kinds of torque? Very good. Excellent. You minions are loving it and you are understanding it. Very good, minions. Very good. Keep it up. Yes, SP, it's more than 2 hours. And you should be ready even if I take it for 4 hours or 3 hours, because this is a 0 to hero series. If you want to be a hero, you have to struggle. Yeah, all actors have struggled. Everybody, Amitabh Bachchan, Amir Khan, you take any actor, nobody was born with a silver spoon, nobody became a star overnight. If you want to be a hero, you have to struggle. Understand that. All right. So, okay, very good, very good, very good. Excellent day. Now, yeah, that's why objects move in the thumb's direction if you pin them. Is that, sir? No, Andrew. See, the direction of rotation is always in the direction of curled fingers. The thumb is used for convention, for notation on how you should actually hold the thumb so that the fingers will curl in a particular direction to get the sense of rotation. That's it. Okay, very good. Now, okay, so a lot of things being discussed over here. One last thing that I would like to tell you over here before going to the next slide. If you have, see, a lot of people get confused. Sir, when to use this formula, R cross MV, and sir, when to use I omega? Okay, so many people have this confusion. So let me remove this confusion first of all. Now, see, this formula is like momentum is mass into velocity. Instead of velocity, you have omega, angular velocity. Instead of mass, you have moment of inertia. And instead of momentum, you have angular momentum. So this formula resembles very closely to this formula of translation. Now, what I want you to understand is that this formula over here is used when you have a particle or a mass and it has some velocity, it is at a distance. So this is used for particles. Yes, this is used for particles, not for a body. It's used for a point mass. Yes, particles or point mass. Whereas this formula, I into omega, it is used for a body which is rotating about some axis. For this body, you will use this. Is that now clear? Understood? Everyone? Yes, Prince, you are all my heroes. Yes, glad Nishant. Yes, Soumitra. Very good, Nishant. Okay, yes. Now you might be wondering, if this question came in your mind, you are very genius, guys. I mean, like, really, you are thinking a lot. What if there is a body which is rotating but also moving? It is rotating and also moving. Then what will you do? Sheikh, the name of the teacher is mentioned in the description box and even in the lecture title. Yes. Achyut, kya ho gaya? Oh my God, Achyut, what is this? Achyut, calm down first of all. Achyut, what is this? Chill, man. I'm trying to make you a hero over here and you're talking about suicide? No, Achyut, come on, chill. It is not, I mean, you should not even think so negatively, Achyut. We are all, yes, Achyut, I know you might have told your problem, Achyut, but understand that bacha, nothing is over. I know your parents might scold you, your relatives might scold you, your institution might be bad, your coaching might be bad. I know that you are facing all these problems because of your coaching, and please understand that it is not you alone. Many people are facing those difficulties. So please get rid of that coaching. Please get rid of that environment. And even if you are there, take your mobile, watch our lectures freely, and okay, stay motivated. Make sure that you are learning from us whenever possible. And please understand, you can sit at the back bench, you can sit somewhere else. Utilize your time wherever possible to study for JEE. Don't worry, you can crack the April exam. Do not see, if you feel that March is very close, April attempt is there. April attempt, you can crack it, and I'm pretty sure after April attempt you still have time to crack the board examinations. And believe me, whatever you study for JEE will be helpful for JEE as well. Boards as well. So please, Achyut, calm down. Okay, don't think negatively. We all minions are there. Alright, look at this. Look at so many happy faces. Do you think all the minions out here don't have problems? They all have problems. They all are facing difficulties in their own way. But we are staying strong. We are going to prove all those negative people wrong. We are going to make sure that we are going to emerge in a very successful way. We might not become All India Rank 1. I'm not saying you are going to become All India Rank 1 by attending the lectures here. Maybe, maybe not. It depends. But you will definitely be much better than what you would be had you not attended these classes. So don't worry, Achyut. Okay? So stay positive. Yes, we are all there with you. Okay, cool. Yes. So I was just saying some time back that, also, by the way, Abhishek sir made a very good video on spectrum. Please watch that video. In case you haven't watched it, sorry for that interruption, guys, but I think it is very important for me to tell you this. So please watch that video on Spectrum channel. Abhishek sir had made it. Just 1 second. Oops. Yeah. So yeah, this is the video, very important. Please watch it by Abhishek sir on Spectrum channel. So please do watch it. Okay, so not just for Achyut but for everyone, guys. It's very important that you guys see this video. It was a very, very important video. Please do that. Please do that. Okay, cool. Okay, great. Chalo. Having said that, let's continue. Okay. Okay, so I was just telling you about, a rigid body, okay, which is not only rotating. Guys, don't watch the video now, watch it later on. First, let's focus. Yes, first focus on the lecture. Okay, let's first complete our chapter, or else then you will lose all the zero to hero series. Okay, so let's say the axis is moving with some velocity. When that happens, then there are two things you need to do. Two things. First, think of this situation like this entire body is like a particle moving with velocity v. What is this? This entire body is a particle of mass m, all right, moving with some velocity v. Okay, so this same mass m. And also think about that axis, it is just rotating. So that body is just rotating about that axis with some angular velocity. So there is translation and there is rotation. So divide it into two things, all right. So one is the particle and one is the body. Now we know which formula to use for a particle. The formula for particle is R into R cross mv. This is the formula you will use for when you treat that body like a particle. But when you treat it like a rigid body, this will be the formula, I into omega. So the total angular momentum will be the addition of both of them. So for a body which is translating plus rotating, use this formula. Is that clear? Is that clear? Everyone understood this? Everybody understanding this? Excellent, excellent. Very good, minions. Okay, minions. How many minions are strong now? How many minions are feeling much better? Yes, Sujal, I'll definitely reply to you after the session. Minions, are you feeling strong? Are you guys understanding? Okay, lot of concepts getting realized. Next up, rotational energy. Excellent, excellent Priyal, excellent Priyanka, excellent Ruby, excellent Nancy. Very good Anoki, very good Asta, very good Ankit, Neha, very good Sujal, Bujia, very good. Yes, yes, this will be the net momentum. Kirito, yes, very good. Uncharted, hi Josh, excellent Rajshekhar, very good. So Nina is asking, omega is VR or omega is V by R? V is omega R. So remember this, Nina. V is nothing but omega into R. There is a very simple way if you forget it. See, if you have a blade of the fan, tell me which point has more velocity. This point has less velocity, this has more, this has even more, this has even more, right? So don't you see, as the distance increases, the velocity also increases. As R increases, velocity also increases. So that's how V is omega R. That's very simple. Yes, very good. Oh Ankit, please don't remind me of Gulab Jamun. I just received a call from my cousins and they are planning some ice cream party after this marathon session. So I might go and have some ice cream. Not sure. Let's see. Okay, so yes, very good. Now, energy wise, see, if a body is just rotating, if there is a body which is just rotating, okay, about some axis, then use this formula, half I omega square. Okay, that is the rotational kinetic energy. But just like before, if that body is also translating, if it is rotating, like example, this is an example of just rotating body. But H.C. Verma, the teacher, let's say, once had happened, one of my teachers got really angry and he threw that book on somebody's face. He got really flipped. I mean, he got really angry and he threw that book on somebody's face. So that book went flying like this and it was doing translation plus rotational motion. And the thought that came in many IIT aspirants' mind, what should be the rotational kinetic and what is the total kinetic energy? So it will have rotational kinetic energy and then you can assume H.C. Verma's book as a point mass and it will have translational kinetic energy. Okay, so guys, that's how it is. Half m VCM square. So this is nothing but, if you assume it like a particle, so assume it like a particle, and this one is nothing but the rotating part. Okay, so keep this in mind. So this is how the two terms come. Very good, excellent. After you're a little bit late, you missed a lot of fun, but it's okay. A lot of fun is still remaining. So hold on. Okay, so a lot of things are coming up. Yeah, Nancy, practical learning. Oh, by the way, I remember in my coaching, one teacher was there and he wanted to teach circular motion. So he took a duster. So guys, duster, old days, remember? No online learning, old days, blackboard, duster, chalk. Yeah, so he used a duster and he tied a string and he basically, yes, took the duster, tied it to the string and he rotated it and we were all like this, like, okay, please, let's not get hit by this duster, and luckily it didn't hit any of us, and we were safe. Yeah. Okay, so anyways, so Maria, I just said that V is omega r. I just repeated it. V is omega r. V is angular velocity into r. Okay, cool. Let's get going to the next one. Okay, slipping and rolling, very important slide, guys. So, oh yeah, Aishwarya, my God, look at the generation now. It's looking like a selfie stick, it seems. Yeah, chalks and dusters were like weapon. I mean, okay, good old days, whatever. Okay, now I'll tell you rolling in a very simple way, guys. After this, you will never face difficulty in this. See, okay, now, I don't know how many of you can see this, but still, I'll try it, my best. Okay, so my weapons, can you see it? I don't know whether you can see it, or should I use a darker background? Okay, my shirt can be a good dark background. Yeah, Minions, Nagpur family, oh my God, what, we have now families from cities also, glad to see this. Okay, welcome Minions, Nagpur family. Okay, so this is visible, okay, great. Now, imagine, guys, just imagine, I'm going to teach you rolling and slipping. After this, you will never forget it. After this, you will never get confused whether it is backward slipping, forward slipping, non-slipping. What the hell is this? You will never forget. Okay, now, let's do this. Imagine this triangle, okay, imagine this triangle, guys, and it is toppling like this. I hope you can see this toppling point. It is toppling like this, okay, it's toppling like this. And then it topples about this point, a new point. And then it topples about this point. So it is toppling like this, like this, like this, like this. Tell me, when it is toppling about this edge, is this edge moving? Is this lower edge moving? Yes or no? Is this lower edge moving? Is this lower edge moving? Think about it. Is this lower edge moving? Think about it, guys. Gisha, just improve your contrast on the screen. Yes, no, it is not moving. Correct? So it will not move until the new edge is touching the surface, and that new edge will not move. Correct? Very good, very good. Now I'll replace the triangle with a rectangle out here. I hope you can see this. And if you cannot see that rectangle, I always have my phone. Okay, I always have my phone. Okay, so this is our rectangle, guys. So imagine this. Now this rectangle topples. You can see there is an edge about which it is toppling. You can see that this edge is not moving until a new edge comes. That also doesn't move, and it touches the new edge, that also doesn't move, and so on and so forth. Isn't that correct? So do you see, this is moving, or this is rolling in such a way that the point of contact is not moving. The point of contact is not moving. Now think about it, guys. Just imagine this. What if this point slides like this while toppling? Slides like this. Imagine it slides like this while toppling. Is this point of contact then going to be on rest? Is this point of contact then going to be at rest? Think about it. No, right? This point of contact won't be at rest if it topples while sliding like that. Is that clear? So that is basically slipping motion. This is basically slipping motion. Yes. Biju, in fact, I have done all the February questions in all the discussions. All the questions have been discussed, Biju. No point doing it again. It's already discussed. Yes, very good. Now, what is a circle? Circle is a improvisation of a triangle, rectangle, pentagon, hexagon, make many sides. How many sides does a circle have? It has like almost, yes guys, it has infinite sides. You can think of circle as infinite sides out there. So think about it. When I move this circle like this, do you see that it is actually toppling over multiple edges? Can you see, guys, it is actually toppling over multiple edges out there? Yes, infinite edges, correct? So that is rolling. So look at this circle, guys. This circle is moving in such a way that, you know, it is toppling about every edge over there. It is toppling, and that is basically no slip. That is called as rolling motion. Very good. Excellent. Now are you able to visualize rolling? Similarly, if I take this circle and if I make it slip like this, if I rotate it more, than what it can, what it should. See, if I rotate it more, do you see the bottommost point is slipping? Do you see that the bottommost point is slipping out there? It's like somebody has pressed the accelerator, the wheel is not moving forward and it is rotating more. It's rotating more, it's slipping out there. So that would be basically slipping. All right, that is basically slipping. I hope this is clear now. Very good, very good. Now, what I want you to understand, there are two kinds of slipping. There are, yes, wheel in the mud, yes, less traction on the surface. Thank you, Yashwant. Now, there are two kinds of slipping. One is forward slip, one is backward slip. Okay, one is forward slip, one is backward slip. Now, what is the difference between the two? I want you to understand. Okay, so usually when a wheel rolls, all right, like for a car or a bike, usually it is rolling unless and until it is stuck in a mud, or you're pressing the accelerator too hard, or it is skidding, or you're drifting. Usually the wheels of a car or a bike or a truck will roll. In slipping, what are these two kinds of slipping? I'll tell you. Look at the center. If the center of the wheel, okay, if the center of the wheel has some velocity, this is the wheel, and if the center of the wheel has some velocity, the wheel is moving with some velocity, and this point of contact, think about it, this point of contact, if it is eventually moving forward, usually in rolling what happens, that point of contact comes at rest, right? But imagine the wheel is not rotating much. Imagine the wheel is not rotating much. Imagine then that point of contact, just pay attention to that point of contact, guys. Isn't that sliding forward? Isn't that sliding in the direction of the center of the wheel? That is called as forward slip. Yes, Tokyo Drift is kind of forward slip. Very good, Ninat. Yes, look at that again. That point of contact is moving. That point of contact is moving in the direction of the velocity of the center. That is called as forward slip. Okay, so that is forward slip when you apply the brakes really hard. Keep this in mind. Similarly, guys, similarly, yeah, when you accelerate too much, look at this. The wheel is turning a lot. The wheel is turning a lot. The wheel is turning a lot. Look at the bottommost point. Look at the bottommost point. Where is it moving? It's moving that way. The bottommost point is moving that way, and the center of the wheel is trying to move that way. The center is moving that way, the bottommost point is moving that way. So that is called backward slip when both these directions are opposite. Is that clear? Is that clear? So Anu, take a wheel, take a protractor, take a these kind of rolling elements, whatever is available around you, take a bangle, take a ring, and try to do this so that you will understand. Okay, so that's it. Okay. No, minions, I don't know, but maybe you can reveal it. Okay. Cool. Minion Nagpur fam. Okay. Yes. I'll repeat backward slipping once more. I'll take one more thing so that you will understand it better, hopefully. Okay. 1 second. Okay. Check this out. Okay. This must be easier. Okay. I hope you can see this. So look at this, guys. If I rotate it like this, okay, if I roll it like this, then the point of contact is at rest. But imagine I move it or I rotate it more, I spin it more than what it should. I spin it more than what it should. Look at the bottommost point. Where is it moving? That bottommost point is moving there. The center of the wheel is moving there. So when the bottommost point, the point of contact, and the center of the wheel are in opposite directions, that is called as backward slipping. I hope that is clear. Is that clear? Yes. So backward slipping is when you accelerate really fast, the wheel spins a lot, it is hardly moving, so the point of contact moves opposite, not backwards, opposite to the center velocity. That's how it is. Okay. Now if this is clear, okay, now understand this. Oh, okay, Sujal, oh my god, you have come up with a new name, glad, nice to know. Now, only for rolling, V is omega r. Keep this in mind. Only for rolling, V is omega r. But for forward and backward slip, is V equal to omega r? No. In fact, the point of contact will have parallel velocity to VC, center's velocity, and VP will be anti-parallel to VC in case of backward slipping. Keep these pointers in mind, guys. Keep these pointers in mind. I'm coming to friction now. Okay, I'm coming to friction. All right. Now, yes, it's like spinning back a marble. Yes, Andrew, correct. Shield gaming, the class is going to be a little bit more than 9 o'clock. Okay. Yes. Now what I want you to realize, in case of rolling, the friction is static in nature. Guys, just think about it. When it was going like this, or when this triangle was toppling over one of these edges, wasn't that edge at rest? So what kind of friction will be there at that edge? Static friction. So same way, when this circle rolls, understand that friction which will be there at the bottommost point will be static friction. Understanding this friction will be static friction. So that's why I put the friction will be static. That is called as rolling friction. Keep this in mind. What is the value of static friction? Please don't say it is mu n. That is wrong. It can be anywhere between 0 and Fs max. It can be anywhere between 0 and Fs max. Keep this in mind. Okay. So it can be anywhere between 0 and mu n, which is Fs max. Also keep this in mind, since the point of contact, when anything topples, look at that, the point of contact, is it moving? No. Is force acting? Frictional force? Yes. The point of contact is not moving, but there is force. So will there be work done? Yes or no? Think about it. When it is rolling and it is toppling about one edge over the other, will there be work done by that static friction? What do you say, guys? Yes or no? No, right? Exactly. Very good. But if that point of contact slides like this, then guys, what will happen? Will there be work? Yes or no? Will the point of contact, if it slides, what kind of friction will be there, and will there be work? Yes or no? Vishal says yes. Very good. Yes. So in drag race, when it starts, it will be backward slip. Yes, correct. Yes, Sujal, correct. Yeah, correct. Yeah. So understand that will be negative work. Very good. And the friction will be kinetic in nature. Yes, Zekron, this video will be available after the video ends, but it's always better to attend it live, or else you will not have fun. Okay, kinetic friction. Very good. Similarly, for backward slip, forward slip, any kind of slip, the friction always is going to do negative work because it is going to suck away the energy. Okay, I think this thing didn't come out properly. This is Fk, by the way. This is Fk. Okay, this is always kinetic friction, which is mu k into n, and always it will do negative work. Very good. Very good. Thank you, Vishal, so much. Hello, Vatsalya. I guess you joined in a little bit late. You missed a lot of fun, but it's okay. Join in now. Okay, shall we go ahead now? Okay, done. So most of the theory of this chapter is over. Are you now ready for problems? Are you now ready for problems? Sunil will come up with a plan for JEE 2023 also very soon, because your board exams have been delayed. So that's why all the plans also have been delayed a little bit. Okay, let's get ready. So let's drink some water first. Come on, guys, call your friends, call your classmates, call your batchmates. It's a Saturday evening. Shreyas Sir is on live. Yes, come on. Ruby, this is for JEE 2022 as well. Yeah, this is. Oh, Andrew, there is nothing like pure rolling. I mean, rolling only is pure rolling. So there is nothing like pure rolling is different from rolling. Pure rolling means rolling, or rolling means pure rolling. Neha, you can approach me on Instagram more than Telegram, because Telegram will get spam. So approach me on Instagram, or just put a comment after the video. I'll respond to any kind of queries that you have. Okay. Hello, Arpana. Rajshekhar is asking, how many bottles do I have? You should count every time I come up with a new bottle. Now this one is a copper bottle. Yeah. Will you be online? I don't know, Ultra, but yes, I'll try and respond today. Okay, cool. Backward slip example, Earth, correct hai na, Naveen? Earth is not slipping on anything. It's free in space. It is revolving. So it is not an example. Yeah, okay. Shubha, you are asking, if I join the crash course after the results are out of the first attempt, will it be too late? No, Shubha, it will not be too late, but it will be late. So earlier you join, the better it is. Okay, so I'll tell you what the surprise is. Yes, Somil, you can watch this for NEET as well. Okay, let's do this. Now the surprise is, that there are no questions. Yeah, there are no questions. We are going to make questions. Are you guys ready? The surprise is yes, we are going to make questions today. How about this? Yes, let's do this. And for that, let me bring my other board. Okay, and let's do this. I am not kidding. We're going to make questions today. Okay, let's do this, because yeah, usually people come prepared with slides and this question, that question. So let's make questions. So let's start with something very simple. Okay, so imagine, guys, okay, so this is a rod, and for a rod, we know if the mass is m and the length is L. Okay, so this is a rod. What is the moment of inertia about the central axis? We all know it is ml square by 12, correct? It is ml square by 12. Very simple. Now, yes, it's going to be fun. Now you observe what I'm going to do. You're going to have fun. Trust me about this. Now, I just told you a property saying if you take any 2D object and you stretch it, the formula of moment of inertia never changes. What did I say? If you take a 2D object, 1D object, you stretch it like ring into hollow cylinder or a disc into solid cylinder. So if you take a rod and you stretch it, what do you get? You will get a plate. You will get a plate, right? So you are going to get a plate out here. Okay, and then this would be my axis. The same value of moment of inertia will be there about this axis. Do you agree with this? Yes, you're going to get a rectangular plate about which the moment of inertia will still be the same. Now, how about choosing another axis like this? Okay, another axis like this, and about this axis, assuming, for example, this was length L, and let's say this was length B. Okay, about this axis, what will be the moment of inertia? Guys, think about it. If about this axis, okay, if about this axis it is ml square by 12, and I rotate the plate like this, about this axis, what will be the formula for moment of inertia? Come on, guys, let me know in the chat box. Let me know in the chat box. Yes, 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 very good. It will be mb square by 12. Instead of L square, it will be b square by 12. Same thing. Instead of rotating it like this, I'm rotating it like this. Great. Now, let's use perpendicular axis theorem. What shall we use? Let's use perpendicular axis theorem. So about this axis, it is ml square by 12. About this axis, it is mb square by 12. So about this axis, like this, what would it be? It will be ml square by 12 plus mb square by 12. Correct? So this is using perpendicular axis theorem. Perpendicular axis theorem, you will get this as the answer. Very good. Now the magic is not yet over. Now comes the real magic, guys. Now what if I do this? Yes, I take this plate and stretch it. If I take this plate and I stretch it, what will it become? It will become a cuboid, right? It will become a cuboid. Just visualize this. Just visualize this, guys. Where, you know, this one is, let's say, I don't know, maybe L, maybe this one, which was B, and let's say the height out there was H. So look at that, guys. Now the axis that I'm talking about, where did it go? Yeah, the axis that I'm talking about, the red one will be something like this. Check this out. Wouldn't the red one will be like this? Isn't that clear? Isn't that clear? It will become a cuboid. So guys, now think about it and tell me what will be the moment of inertia about this axis for a cuboid. What will it be? It will be just ml square plus b square, all right, common, divided by 12. There is no h in the answer, isn't that? Very good. Yes, so stretch this, it will become cuboid. So that's the formula for a cuboid. You don't have to memorize it separately. It's so easy to visualize. It's so easy to visualize. Isn't this fun? Understood? Very good, very good. Chalo, let's go to the next problem then. Okay, let's go to the next problem. Don't worry, all the pages are there. Okay, so all the pages are there, so nothing will get erased. Okay, great. Now let's take another problem. Let's try and think about something else. Maybe Okay, so let's see. Okay, cool. So let's take a semicircle. Let's take a semicircle and let's try to find moment of inertia about different points. I want to find the moment of inertia about this point. I want to find the moment of inertia about this point. I want to find the moment of inertia about this point. Now, every time these kind of problems come, people find it very difficult. People find it very difficult to solve these kind of problems. So how about, solving different kinds of variations on moment of inertia? Let's do this so that you will never find it difficult. Okay, Yashas, you can just rewind back the lecture a little bit so that you get the answer for that. Okay, so just rewind back. Cool. Hello, Senthil, welcome, join in. All right. So let's start with this. First of all, let me call this axis as 1. Let me call this axis as 2. Let me call this axis as 3. So different axis, I want to find the moment of inertia. Now, what I'm going to do is, think about it. If I want to find the moment of inertia for the axis 1, this is a semicircle. This is a semicircle, okay, and the ring radius is r, the mass is m. Keep this in mind. Keep this in mind. If I complete that semicircle, okay, if I complete that semicircle something like this, okay, if I complete that semicircle like this, then the moment of inertia for each half part will be I1 and I1 only. Think about it. For this half part, whatever is the moment of inertia about this particular axis, okay, this axis number 1, the same moment of inertia will be there for the other half also. Do you understand? It's a ring. I said probably it's a ring. Okay, semicircular ring, okay, cool. Everybody getting it? Yes. So now think about it. What will be the formula for the ring, the moment of inertia of a ring, complete ring? Won't it be mass of the ring? Now be careful, the mass is no longer m, it is 2m. What is the mass? It is 2m. Be careful, this is the common mistake. 2m into r square. That's it. That's the moment of inertia of the ring. I'm just saying, Rishabh, that if this semicircle about this axis had moment of inertia I1, another semicircle about the same axis will also have the same moment of inertia. So two semicircles make a complete circle. So the complete moment of inertia of a ring, a complete ring, will be just mr square, but the m is 2m. Is that now clear? Is that now clear? Understood, Rishabh? Very good. Very good. Great. Now, can I say this moment of inertia of the ring is 2 times I1? Isn't that clear? 2 times I1 is 2 mr square. So guys, what will be the value of I1? I1 will be just mr square. Very interesting. I1 will be just mr square. That's it. Yes, it will be just mr square. That's it. So we have got the first answer, whatever we needed. Very good. Now let's try to find about 2 and 3 also. Let's try to find it about 2 and 3. How do we find it out about 2 and 3? Let's think about it. Okay, but before that, I think finding 3 is very easy. Finding it about 3 is a little bit easy, and I'll tell you how. Okay guys, now pay attention to this. Okay, now this point 3 is over here. This point 3 is over here, correct? Whatever is the moment of inertia about for this left side, about this third point, the same moment of inertia will be also there for this side. Think about it. About point 3, whatever moment of inertia this semicircle has, the same moment of inertia even this semicircle will have. Correct? Yes, very good. So the moment of inertia about this point 3, the moment of inertia about this point 3, okay, for that ring, okay, for that ring at that point 3 will be the moment of inertia about center of mass, which is over here, and shift it. First shift it. Yes, just shift it by how much distance? R distance. So plus m. Oh, be careful, it is not m, guys. Why is it not m? Because the ring has a total mass of 2m. M becomes 2m. So it will become 2m r square. Is that clear? Shift. This is nothing but the shift of parallel axis theorem. The shift of the parallel axis theorem. Be careful. Okay. If that is clear, what is the moment of inertia about center of mass? This one. So it will be 2m r square plus 2m r square. Correct? The center of mass moment of inertia is just 2m r square. But what is this going to be? This is going to be twice of I3. Think about it. this is going to be twice of I3. Is that clear, everyone? This is going to be twice of I3. So now 2, 2, 2 cancels. So I3 will be just mr square plus mr square. So I3 will be just 2mr square. So that is the answer for moment of inertia about the third point for a semicircle. Is that clear? Understood how to solve this problem? I hope everybody is getting a sense of how to use visualization, parallel, perpendicular axis theorem, etc., etc. Easy? Okay, great. Now there comes a very interesting thing. Let me just remove all of this. It's no longer needed. The only thing remaining now is to find about 2. How do you find out about 2? Let's see how to do this about point 2. Now, any ideas how to do it about point 2? It's not so easy. I'll tell you why. Because even if you complete a circle, for that point 2, this semicircle is different from this semicircle. Because this semicircle is closer over here. This semicircle is far. I hope you understand that. Correct? So, when you took point 3, then this semicircle or this semicircle was same. But for that point 2, you cannot do it. So, let's see what do we do. Rishabh, contact me on Instagram, alright? Not on email ID. My Instagram ID is mentioned here. Okay, welcome Ashwani, welcome to this channel, Zero to Hero series. We have discussed the theory, now we are doing problems. So I'll tell you what, you'll have to use parallel axis theorem. Yes, we have to use parallel axis theorem. So I know what many of you are going to think. I2 will be I1 plus md square. What is the shift? Oh, shift is nothing but r. This is not correct. What is wrong in this? Arpna, this is not a Hindi channel. Hindi channel is there separately of Vedantu itself. That is called as Vedantu JEE channel. Please go ahead and follow that channel if you want to learn everything in Hindi. Okay, so this is an English channel. Okay. Oh, this is a very, very critical thing, guys. You cannot use this because I1 is not the center of mass. Yes, it is not the center of mass. Okay, I hope this is clear. Yes, this is not the center of mass. No, it's not about 2m. It's not about 2m. I1 is not the center of mass. Be careful. So you cannot use this. First of all, understand that for this semicircle out here, the center of mass is somewhere here. Yes, this is the center of mass. This is point 1 and this is point 2. Keep this in mind. This is the semicircle center of mass. And this distance d, you should know that formula. Be careful. Yes, that formula for a semicircle, it was it was just r sine theta by 2 divided by theta by 2. Correct? This was the formula. And theta is the angle which is subtended. The angle which is subtended is pi. Alright, it was pi. So that 2 goes there. So sine 90 is 1. So 2r divided by pi is that distance out there. So that is the distance from the center. Great. Now what you should do is observe this. Observe this. Did I not just find out I1 just some time back? What was the value of I1? We just figured it out. What was the value of I1, guys? What was the formula for I1? Okay, so Rishabh, this is a standard formula for center of mass. Please watch my Zero to Hero series. This is from center of mass chapter. Alright, please watch the lectures from center of mass. This is a standard result. Center of mass of an semicircular arc or any arc. This is a general result. Okay, so going back. Okay. Now think about it, guys. Yes, we just figured it out that it was just mr square. Excellent. We just figured it out from previous result. Okay, we figured it out from previous result. Now, can I say I1 is equal to ICOM plus MD square? Is this correct, guys? Everybody understanding it? Parallel axis theorem. I parallel is center of mass moment of inertia plus M into shift square. Isn't that clear? Similarly, think for moment of inertia about 2, what will be the moment of inertia about axis 2? It will be ICOM, but instead of MD square, what is this distance? What is this distance? It is R minus D. This is R, this is D, this is R minus D. Is that right? So this will be R minus D whole square. Keep this in mind. Yes, is this clear? Is this clear? Everyone? Glad, Ashwini. Yes. So concentrate, Arpana, others. Yes, even if if you're facing some difficulty, please replay it back a little bit. Please replay it back. And Ranisha, please post all your doubts in the comment section or ping me on Instagram. Definitely I'll help you out. Okay. So guys, now what do? Just subtract them. Just subtract them. So I2 minus I1 will be equal to center of mass will get cancelled, right? So M into R minus D whole square minus, okay, MD square. Just subtracting. I2 minus I1 is this minus this and this minus this. That's what I have done. And I just know what is the value of I1. I1 is MR square. Alright, I1 is MR square. And this is nothing but M into R minus D whole square minus MD square. So, therefore, I2 will be equal to, shift this term over there, and you will get MR square plus M into R minus D whole square minus MD square, and whatever value of D you got, just substitute it here and here. That's how you need to solve the problem. Thank you, Rishabh. Thank you. Thank you. Okay, great. Understood how to solve these problems? So understood what is the catch? These kind of questions can come in the JEE Mains examination. So I wanted you to understand, when it is not the center of mass, you can use parallel axis theorem 2 times and you can eliminate the unknown variable. Heather, there is no Vedantu channel for Tamil beta. That is a long-term goal. Let's see when that happens, but it's better to learn in English now. Okay, cool. So you should be happy that you have an English channel at least. Tamil is too, I mean, I'm guessing you are having too many expectations now. Okay, cool. Yes. Yes, when you are considering the full circle, point 3 will be same, point 2 will not be the same, Andrew, because for point 2, this part of the circle will be at a different distance. This circle is like this, it's rotating about axis 2 like that. That part will be different. But for 3, the left side or right side both will be same. That's why. Okay, very good, great. So having done this, let's go ahead. Let's do some questions on torque also now. Okay, so let's see how many of you can do this. Okay, great. Okay, so let's take an example. Say for example, okay. Okay, and let's say my point which I want is over here. Okay, and let's say I'm going to put some forces now. Yeah, like this. Then another force. Okay. Okay, chalo, done. Okay, cool. So these are the forces. This is F1, this is F2, this is F3, this is F4, this is F5, this is F6, this is F7, this is F8, and this is F9. Okay, this is F9. So these are the forces acting on a rectangular body which is pivoted about point O. This point O is nothing but the pivot. Okay, so guys, let's do this for everyone. Okay, so we are going to find what is the direction of the torque. F1, F2, F3, F4, F5, F6, F7, F8 and F9. Okay, chalo, let's do this. For F1, what do you think is the direction of the torque? Come on. Oh, they are all forces. Yes, F1, F2, F3. Yeah, I'm not sure what you guys thought. So what are the direction of the forces? Come on, guys. Oh, sorry, torques. This torque because of F1 about this pivot point, will it be clockwise or anti-clockwise? Very good. It is going to be clockwise. Very good. Remember the trick I told you? Rotate that force about that pivot point. You will see it. F2 will rotate about that point O. I think that will be anti-clockwise. I hope you can see that. Yes, Aditya, I think it should be similar, but concentrate on the class. Yes, it will be anti-clockwise. F3, try to rotate it about that point O. Try to rotate it. Take F3 and rotate it about point O. Yes, it will be also anti-clockwise. F4, F4, very interesting. F4, come on guys. What is F4? Think about it. Think about it. What is F4's torque going to be? F4, 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 F4. Be careful. F4. Yes, Aishwarya is correct. It is 0 because F4 is passing through that point. Oh, be careful. It is 0. Yes, Manish. Yes. Yes. Very good. Very good, Anu. That is going to be 0 torque. Be careful. Okay, because it is passing through that point. Oh, be careful. F5. F5 will produce what kind of torque? F5. I think it's going to produce clockwise torque. Correct? It is going to produce clockwise torque. Understood? Similarly, F6. F6, what will F6 do? It will produce, F6 is passing through the pivot. It will not produce only any torque. Be careful. F7, be careful. What will F7 do? F7, try to rotate it guys. Try to rotate it about point O. Yes, it is going to produce anti-clockwise torque. Yes. And what about F8? F8 is going to produce again, rotate it about that point O. Yes, anti-clockwise torque. F9 will produce clockwise torque. Yes, F9 will produce clockwise torque. Now please understand, whatever is the resultant of this, so the net torque will be moment of inertia into alpha. This net torque will be moment of inertia into alpha. Keep this in mind. Okay, very good. Now let's create a problem out of this. Okay, now let's see how many of you actually can do this. Oops, my bad. Where is that undo? Yeah, okay. Now there is a rod. Okay, there is a rod. Okay, and there is a point mass in the end. Okay, there is a point mass in the end. And this rod is, let's say, pivoted. It is, yeah, there is a point mass M and the rod's mass, all right, the rod's mass is 3M and the length is L. And let's say it is pivoted like this over here. This is the pivot point. Now, there are a couple of questions over here. Let's see how many of you can get this. Very interesting. So the question is, when released, so when you release it, all right, find angular acceleration. So the question is, find the angular acceleration of that rod. That's the question. Let's do this. Let's do this. Okay. Well, Arpana, whatever doubt you have, please definitely post it out. Don't worry. Okay. Now, what is pivot? Pivot is the hinge. It's like about that axis, it tries to rotate it. Okay, once it tries to rotate about that point, like me holding the pen here, that's the pivot, or me holding the pen like this is the pivot, this is the hinge. Okay, fine, great. Now, how do you do this problem? Let's see how do we do this problem. It's very simple, guys. So first of all, start with the forces acting on the rod plus the point mass. What are the different forces acting on the rod? Yes, what are the different forces acting on the rod? Well, I think one, there will be some kind of a normal force. There will be some normal over here because there is a pivot. It is being held over there. So there will be some kind of reaction force. Yes. Similarly, Arpana, nobody can tell you why like charges repel and why unlike charges attract. I can ask you another question. Why will a mass dropped on earth, why should it fall on earth? What is the reason behind that? Why should two masses attract? So there is no reason for that. All right. That's the most fundamental thing. We assume it is to be true. So if you find the answer, you will definitely win the Nobel Prize. Hello Siddharth, good evening. Yeah. Okay. And gravity, but there are two kinds of gravity. One is the gravity on that rod. Be careful. Gravity on the rod will be 3 mg. Correct. The gravity on the rod will be 3 mg. And what will be the gravity of that point mass? It will be just mg. Correct. It will be just mg. Very good. And once you show the forces, do not forget to show the angular acceleration. This will be alpha. Angular acceleration. It will try to rotate like this. Now let's start from the basics. What will be my basics? Net torque will be moment of inertia into alpha. Net torque will be moment of inertia into alpha. Okay. Now my question is, Is the moment of inertia going to be so simple? No, you have to first figure it out. It's not so simple. So let's try to figure out what is the value of I and what is the value of torque, everything properly. Let's start with the LHS first. Is normal going to give any torque about the pivot point? Is the normal going to give any torque? Come on guys, let me know in the chat box. Is the normal going to give any torque about the pivot point? Okay, Sejal, it will come later on, don't worry. Yes, it will not give any torque. Will 3mg give torque? And if it gives torque, which kind of torque? Clockwise or anti-clockwise? Clockwise or anti-clockwise? Think. Will 3mg give torque? 3mg, will it give torque? And if it gives, what kind of torque? Yes, it will give torque. What kind of torque? 3mg will pull it like this, clockwise. Look at that. It is going to give clockwise torque. It's going to pull it like that. So, plus R. R is, what is this distance? It is L by 2. Be careful. It is L by 2. This is exactly at the center of mass into 3mg. Very good. And this mg is also going to give a clockwise torque. So I will add it. So plus L into mg, correct? So this is the complete LHS. I hope you understand it. I hope you understand it. Yes, very good ones. Nice smiley. Okay, so LMG. Now, moment of inertia will also be two moment of inertias. Okay, Mohammed, please watch the lecture from beginning. And another thing, Mohammed, you can do one more thing. Watch my flash series. Only then you will catch up. Because if you are joining somewhere in between, I am pretty sure if you do not have any idea about it, then it will be difficult. So please watch it from the beginning or watch our playlist from the flash series on rotation. Yes. So guys, what will be the moment of inertia? There are two moment of inertias. One for the rod. Yes, this I will be for the rod plus that particle. Two moment of inertias are there. For the rod, what was it about the end? Wasn't it ml square by 3? For center it was ml square by 12. For the end it was ml square by 3. But what is m? M is 3m. So 3m L square by 3. I hope you understand that. This was because it was at the end. Using parallel axis theorem. Using parallel axis theorem. Remember that. Alright, correct. Plus point mass about the pivot. How much moment of inertia will it have? Point mass about the pivot point. How much moment of inertia will it have? Be careful. Point mass about the pivot point. How much moment of inertia will it have? Just ml square. Correct guys? Just ml square, nothing else apart from that. So that's it. So just do this math and you will get the answer. So first of all, yeah, this will be 3 by 2 plus LMG. So that means 3 by 2 plus 1 is 5 by 2. So 5 by 2 LMG is equal to 3 goes ml square plus ml square. Oh, I forgot that alpha, my bad. Alpha will also be there. So 3 goes ml square plus ml square, 2 ml square. So 2ml square into alpha. Now it's the time to cancel off unwanted things. Like one of the L will go, okay, one of the M will also go. Okay, that's about it. And therefore, I will get, take this 2 below, take this L also below. So you will have 5 G by 4L. Alright, 4L is equal to alpha. That's the answer. Is that clear? 5G by 4L. Yes. So Asta, I'll repeat. Each force will produce a torque. 3mg's torque will be R cross F. What is R? L by 2. Correct? L by 2 into force. This point mass, that weight will also produce a torque. But the distance is more. What is the distance? L. L into mg. So that's what the LHS is. Yes. Sejal, it will be up on the NTA website. Okay. Understood. Very good, Prachi. Very good. Very good. Why rod is not ml square by 12? Yes, I just did it. Remember what that was one of the problem. For center it is ml square by 12. When you go at the end, what will you do, beta? Use parallel axis theorem, correct? So about the end it will become ml square by 3 because you have to use parallel axis theorem. Understood? Understood? Yes, Dora, I think, and somebody else. Yeah, yes, I hope that is clear. Yes, Bajaj. Okay, understood. Be careful. Okay, very good. Okay, very good. Excellent. Now let's go to another problem. Guys. Very interesting. Yeah. So where will the moment of inertia be? 2ml square, 2l square by 3. So you have to find it out using parallel axis theorem. Use it. Okay. Yes. Now let's do more questions. Yes, we are going to do more questions. Now look at this. Okay, I'm just going to make another diagram now. Okay, very interesting diagram. Okay, so say for example something like this. Okay, 1 second, I'll just use a line. Okay, and this, let's say, is the pivot point over here. This is pivot. Okay, and let's use a spring this time. Okay, let's use a spring this time. Oops. Yeah, 1 second. Okay, there is a spring constant K, and let's also put a dotted line over here. Okay, this is that dotted line, and let's also mention what that angle is. Okay, let's say that angle is 60 degrees, or maybe even less, maybe let's say just 30 degrees. Okay, so this is a rod. Okay, I hope you can visualize it. This is a rod of mass M and length L. Okay, now I hope you have understood how the diagram looks like. Now the question is, okay, when the rod was vertical, that time the spring, okay, the spring was at natural length. It was at natural length. Now somebody did some mischief. They pulled that, yeah, they rotated that rod and they are leaving it. Okay, they are rotating that rod and leaving it. Okay, just assume that. So the question is, find the magnitude of the angular acceleration when it is left from the given position. Just from the given position, if it is left, what do you think is the magnitude of the angular acceleration? Everybody understanding this? Okay, so once, that's by convention, not force into, it's not radius, it's force into distance, it's not radius. It is r cross f by convention. If you take f cross r, it will end up rotating in the other way. That's by convention. Okay, very good. Now let's do this. Everybody understanding this situation? First of all, tell me guys, what do you think is the extension? What do you think is the extension of that spring? First, let's figure that out, because that is what is very important. Without getting that extension, we cannot do anything else. So, what will be that extension? Come on minions, let me know in the chat box. What will be the extension in that particular spring? Think about it. What will be that extension in the spring? Yes. By the way, all these questions, whatever I'm doing, none of this was prepared before. All of this I'm thinking on the spot and making it for your understanding. I'm adapting to whatever you guys are understanding. Yes. L by 2. No. It will be L. This is the complete length. L sine 30. L by 2 sine 30? No. L sine 30? Yes, correct. So I think most of you said L by 2. Very good. L sine 30. Very good minions. So that is going to make it L by 2. Excellent. Now think, what will be the direction of the spring force? What will be the direction of the spring force? Which direction will the spring be acting? Think about it. Yes. Which direction will the spring be acting? Force be acting? It will be acting this way, right? So the spring force is going to be like this. This is the direction of the spring force. Okay. What will be the value of that? That will be K into X. So what is K? K is K. What is X? X is L by 2. So the value of the spring force will be KL by 2. Everybody understanding this? Very simple. Yes, towards the left side, and it is Kx towards left side. X is L by 2. Now, about the pivot, what are the different forces which will produce torque? Yes, the spring will produce torque this way. The gravity will act like this. The gravity will act like this, and that would be mg, right? That would be mg, correct? Everybody understanding this particular pointer? Very good. Now think, a normal might also act over here. This normal is of no use because it will not produce any torque. So let's just forget about it. Now comes the challenge. Where do you think it will accelerate? Will it accelerate that way, anti-clockwise, or will it accelerate this way, which is clockwise? Let me know in the chat box. Yes, I know, Achyut. It's very interesting. That's what I'm making you realize you can actually make questions. Hello, Vignesh, join in. Will it rotate anti-clockwise or will it rotate clockwise? Well, some of you are saying anti-clockwise. Yes, is also Nancy, Priyanka, everybody saying anti-clockwise. Well, that is wrong. How can you be so sure? How are you not? How are you saying that it will actually go that way? Because the weight can be actually more. No, Aishwarya, it might not even balance. Yes, it depends on the K. If the spring is not strong enough, why will it go there? What if the weight is more? Then it can actually fall here. So you understand what the examiner is asking. Do you see this? Magnitude of angular acceleration? Magnitude, because the examiner is also not sure to which way it is going to accelerate. This way or this way? Or maybe both will balance. So depends on mg and k, everything. So that's why, what will we do when we do not know anything? Assume it in some particular direction. Just assume that it is in some particular direction. So let's just take it, I don't know, maybe this way. Let's just take it this way. There is no harm, because I'm just calculating the magnitude. Understood? Great. Now think about it. The total torque will be torque because of the normal plus torque because of mg plus torque because of the spring. This will be equal to moment of inertia of that rod into alpha. This is our Newton's laws equation. This is our Newton's laws equation. Standard net torque is I into alpha. That's all I have written. Torque because of normal, 0. Why? Because it is passing through the pivot point. Correct? The torque is 0. Everybody understanding this? Correct. Now, torque because of mg. Is it helping alpha? Is it helping alpha or is it against the alpha? Answer this question. Think about it. If mg is there, is it helping alpha? The torque of mg, is it helping alpha or is it against it? Come on, think about it and answer. Yes, Priyal, very good. Yes, it is helping. So that torque should be considered positive. All those torques which help alpha should be positive. Yes, it is helping. Just like forces, F1, F2, F3, F4. All forces in the direction of acceleration are positive. All forces against the acceleration are negative. Same thing over here. So just put that same thing over here. So what is the torque of mg? Now you will be like, sir, what is the angle, everything? Acha guys, I'll tell you one trick. I'll tell you one trick to find the torque. Well, the trick is very simple. The value of torque is R perpendicular into the force. Use this trick. Yes, use this trick whenever needed. R perpendicular into force. Perpendicular meaning you drop a perpendicular on the force. Just drop a perpendicular on the force. This is that perpendicular. This is that perpendicular. This is basically your R perpendicular. Is that understood? So this is R perpendicular into the force. So think about it. What is the value of R perpendicular? That perpendicular will be careful. This is L by 2. L by 2. L by 2. If this is L by 2, how much is this? Because this angle is 30 degrees. This angle is 30 degrees. Everybody getting it? Very good, minions. Excellent. This is 30 degrees. So think about it. This is L by 2 hypotenuse. This is 30. What is R perpendicular? L by 2 sine 30. Opposite. Sine 30. Opposite side it is. So L by 2 sine 30. Excellent, minions. This is R perpendicular into force. What is the force? It is nothing but mg. Correct? So that's it. L by 2 into L by 2 sine 30 into mg. Yes, very good. Now, if you understand why this force has produced a clockwise torque, Shrija, it has in fact produced torque. Okay. Now, next thing, spring's torque. Should it be positive or negative? Come on. Should it be positive or negative? Think about it. Spring's torque, should I take it positive or negative? Let me know in the chat box. Very good, because it is against. Yes, excellente. Excellente. It is going to be negative. How much is the value? Again, R perpendicular into F. What is R perpendicular? Think about it. What is R perpendicular? Come on, minions, let me know. What is this R perpendicular? Because this is going to be your R perpendicular. Think about it. What is this distance? This is 30. This is L. L 30. What is this distance? Isn't this going to be L cos 30? This distance, all right, this distance, isn't it going to be L cos 30? Correct? So very good. L cos 30 into what is the value? Force. What is that force? This force. It will be KL by 2. KL by 2. Very good. Very good. Very good. Abhiram, mg will always act from the center of mass. Standard. Okay, that's why we took it from the center. Is that clear, Abhiram? Very good. KL by 2 is equal to, what is the moment of inertia of the rod? Think about it. What is the moment of inertia of the rod? Isn't it ml square by 3 about this point? For center, it is ml square by 12. Using parallel axis, just like before, isn't it ml square by 3? Ml square by 3 into alpha. Now that we have done this, physics part is over. Let's do maths now. Let's do maths. Okay, sine 30 is half. So therefore, this will become L by 4 mg minus cos 30 is root 3 by 2. So it will become K. L will become L square into root 3 divided by 4. Okay, is equal to ml square by 3 into alpha. Okay, few of the things might get cancelled out. Maybe like just L, maybe that's it. Okay, one of the L's will get cancelled, and just shift that thing over here, and that should give you the value of alpha. So alpha will be equal to mg minus KL root 3. Okay, this has a common denominator 4. This has a common denominator 4. This ml will come below. This ml will come below, and this 3 will go on the top, and this will be into 3. Yes, 3 times of that. So that is the answer. That is the answer. Is that understood? Yes, based on parallel axis theorem. Very good. Very good. That is the answer. So since the question says magnitude, if you want, in the end you can put a modulus sign, because I don't know who is bigger. I don't know who is bigger. Got it? So guys, if mg is more than, let me make a trick over here, a tricky thing over here. If mg is more than KL root 3, then alpha will be positive or negative. If, forget this modulus for some time, if mg is more than KL root 3, then alpha will be positive or negative. Yes, very good, it will be positive. That means whatever I assumed is correct. That means whatever I assumed is correct. Andrew, just replay back the session to parallel axis theorem. I have explained it 100 times how to find the moment of inertia of a rod about the end. For the center, it is ml square by 12. For end, using parallel, you can find it as ml square by 3. And you just replay the lecture here, please. Okay, please do that, bacha. Very good. And think about it, guys. If, for example, mg is less than KL root 3, then alpha will be negative. That means, think about it. Whatever I assumed is wrong, it will actually go the other way. Yes. Very good. Excellent. So Andrew, that's what I'm saying. I have explained how to find the moment of inertia of a rod for end. When you are at the center, it is ml square by 12 for the end, because the rod is rotating at the end, right? So it is not ml square by 12, bacha. Okay, so just watch it again. Very good. Chalo, let's get going to the next one then. Okay, very good. Let's do this. How about taking some pulleys? Yes, let's bring in some pulleys out here. Okay, so we have a pulley. Okay, and let's say, okay. Okay, and okay, one second. Okay, and yes, we can do something more. Yeah, okay, that much is enough, I guess. Okay, cool. So basically, this is like a yo-yo. So this is a yo-yo. Okay. And it's basically a disc, okay? And think of this yo-yo like a cylinder or a disc, and it is rolling down like that, okay? It's rolling down like that. So just imagine a solid cylinder or a disc, yo-yo disc, which is connected from the top via two threads. Okay, there are two threads over here and it is rolling down like this. A small thin yo-yo disc, there are two threads and it is rolling down. Okay, the question is find the tension. The question is find the tension. Yes, very good, very good, very good. Let's do this. Yes, Achut, I am just solving pulley type of problems. Very good. Let's do this. Excellent. I hope you guys are loving this kind of sessions. Very good, guys. Okay, okay. I hope you are loving these sessions, guys. Okay, let's do this. Okay. Now, how to do this kind of problem? First, let's start with FBD. Okay, what are the different kinds of forces acting on this particular disc? Now, what are the forces? Well, one thing is obvious. There will be tension in the string here and there will be tension in the string here. Correct? There will be two tensions. Do not forget that from the center there will be its own weight, which is mg. Okay, that own weight which will be like mg. Excellent. Yeah, like tissue paper. Sometimes the tissue paper rolls down. Very good, Vishal. Yeah. Okay, okay, okay. Godtech, whatever your question is, please type it out. Definitely, I'll take it up. Okay. I don't know, Rids, why the name is yo-yo. Let's not focus on that. Let's focus on solving the problem. Now, won't it also have angular acceleration alpha like this? It's going to rotate like that. Angular acceleration. So, when I look at it from the side view, both the strings will be in the same line. So I will put it as 2t. Okay, because both the strings are in the same line, I'll put it as 2t. Then this is all from the side view, and then there will be mg, and then there will be alpha. Yes, there will be alpha. Let's do this. Okay, 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 okay. Yes, let's do that. Now think about it. If I have to write any equation, what kind of equations will I write? Torque. Okay, let's take the torque about the center. So the net torque about the center, all right, will be moment of inertia of that disk into alpha. Correct? Moment of inertia of the disk into alpha. Very good, Rids and others. Very good. Andrew, maybe I can answer all your doubts maybe a little bit later on. Just focus on the session right now. Okay? Okay. Now, think about it. What will be the torque at the center? Will tension produce torque or will mg produce torque? Will tension produce torque or mg produce torque? Think about it. Think about it. Will tension produce torque? I don't know, Achyut, first focus on the session. Will tension produce torque or mg produce torque about the center? Think about it. Tension will produce torque. Very good, NVD. Mg, no Asta, I don't think so. Because mg will pass through the point, so it will not produce torque. So tension will produce torque about the center. So how much will that torque be and which direction will it be? Is it helping alpha? Think about it. Is the tension torque helping alpha? Is the tension torque, is it helping alpha? Yes or no? Let me know. Is the tension torque helping alpha? Yes. Yes. Think about it. Godtech, whatever your question, I mentioned it earlier. Whatever it is, put it up. All right. If it is relevant. Okay. Yes, it's going to help. So the torque will be R into tension. R into the tension, but the tension is 2t. Very good. Is equal to R into 2t. Krish, you're a little bit late. Okay. So join in. It's okay. Moment of inertia of the disk. Moment of inertia of the disk will be m r square by what? Mr square by what? I request the admin to block Godtech because he's just spamming. Okay. Just block Godtech out there. Okay. Yes, R into 2t, moment of inertia of the disk, which will be mr square by 2, correct? Mr square by 2, very good, excellent, and into alpha. Now R gets cancelled, and what will I get? I will get 2 into, or maybe I can just put t over there, so t will be equal to m r alpha by 4. Now that's a problem. I don't know the value of alpha, guys. I don't know the value of alpha. So how do we do this? How do we do this? If I do not know the value of alpha, I need to do something more. I have missed something. I have missed something. So I need to also consider the fact that the center of mass is actually accelerating. Do not forget that. This center of mass is actually accelerating down, right? Like this. Isn't it accelerating down? Think about it. It's accelerating down like this. So apart from rotation, I have to also consider translation, and I will start with the net force is equal to mass into acceleration. Net force is mass into acceleration. Now think about it. What is the net force? mg minus 2t. mg is helping A, tension is opposing acceleration. Yes, linear motion. So that's why it will be mg minus 2t is equal to mass into acceleration. Very good. Now I will do one more thing. Acha, t is nothing but this. Okay, I will think about it later on maybe. I have one more problem. I have got two variables over here. This is alpha, this is A. Can I write A and alpha's relationship? Is A and alpha related to each other? I think so, they are related, and I'll tell you how, guys. If you look at this diagram little bit, it looks to me as if this disk is having some acceleration and it has some angular acceleration. Isn't it like rolling? Think about it. Isn't it like rolling motion? Isn't? Yes, A will be equal to alpha into R. A will be equal to alpha into R. Excellent. So in fact, I can use this fact right over here, and instead of alpha, I can put this alpha as A divided by R. If I put this as A by R, because alpha will be A by R, think about it, one more R will get cancelled, or I can just put this as MA. That's it. T is equal to MA by 4. Done, done. Understood? Understood, everyone? T is nothing but MA by 4. So just use this MA now. Just use this MA. What is this MA? Think about it from here. Think about it from here, guys. Just substitute it. So mg minus 2t is MA. MA is how much? 4 times of t. Yes, MA is nothing but 4 times of t. So God Tech, I'm just blocking you because you are unnecessarily spamming. Okay, so 1 second. Yeah. Okay, cool. So yes, it will be nothing but 4 times of t. Okay, very good, very good. Yes, very good. So now take that over there. So what will it become? mg will become 6t, correct? So therefore t will be nothing but mg by 6. So that's how you solve pulley related problems. Also rolling was involved. Very good. Understood? Very interesting problem. Very interesting problem. And look at the way we solved. We went via the basics. FBD, Newton's laws, rotational motion laws, torque, everything. That's it. Very good. Understood? Excellent. Let's go to another question. Okay, let's do another question now. Coming up on your screen. Okay. Let's see how to do this. Now, based on toppling, let's do a question on toppling, guys. Yeah. So, imagine there is a almirah or something like that. Okay. And okay, this is a surface, and maybe there is a small obstruction right over here. Okay, so this one over here, oops, yeah, this one over here, this is a protrusion, all right, a small sharp edge, you can say. This is an edge or a protrusion. It's sharp one. Okay, a sharp protrusion, and this is a box, and let's say the height of that box is h, the breadth of the box is b. Okay, or maybe if you do not like these numbers, we can do one more thing. This is L and this is 2L. Example. Now there comes a Pandu and he is trying to push this box like this. He is trying to push this box. Okay, interesting. Okay, thank you, Vishal. Very good, very good. Some of you had this question in the exam. Yeah, Vishal, we are trying to cover all kinds of questions. Thank you, Vishal. Glad that my smile motivates all of you. And I hope all the smiles out here of the minions also motivates each other. And this Pandu can apply a force of, okay, let's say for example 3 mg. He is applying a force of 3 mg. Now what is that m? I'll tell you. He's applying a force of 3 mg, and I'll just mention it over here. The box has a mass of m. Okay. Now the question over here is something else. The question over here is basically, from the bottom, what can be this height? Oops. From the bottom, what can be this height? Okay. So the question is basically over here. I'll just put it over here. So what is the maximum value of that height such that the box doesn't topple? Such that the box doesn't topple. Imagine this, if you're pushing it from a lower height, there are less chances of it to topple. Correct, guys? Yeah, I hope this is clear. Achal bhai, this is not a random place where you can just ask random questions and you will get random answer. And if you want to ask questions, please join the pro subscription, because in pro subscription, whatever doubt you ask will get answered. Okay, very good. Okay, so Krish, I'm not sure if I'll be teaching in Eklavya this year because I'm already held up with other programs and other things, all right, like on YouTube. So, but you will have really good teachers as well this time. Okay. Now think about it. If you apply the force below, there are less chances of it to topple. When you apply the force on the top, there are more chances for it to topple. Correct? So that's how things work. Now think about all the forces that are acting on the system. Okay, one is obviously the mg force. So mg will act from the center of mass. So, all right. So oops. Yeah. Mg will act from the center of mass of that rod. Oops. 1 second, guys. Yeah, this is mg. Okay, very good. Now there might be some friction also, correct? There might be some friction, who knows, it's not given, but let's just assume that there is some kind of friction over here, some F. There will be also some normal. Yes, hiking, yes, I'll teach thermodynamics in a separate 0 to hero series. Now think about it. Trevor Khanna, you're not invisible. Now think about it. Abhiram, yes, that's what we are going to get to. Where will the normal force act from? Where will the normal force act from? Think about it. Where will the normal force act from? Will it act from left side? Will it act from center? Will it act from right side? Or it could be anywhere. Think about it. Think about it. No, Abhiram, that's not correct. That's not correct. That's not correct. Okay. Think, guys. Where will the normal act from? Toppling point? Well, it depends. If it is on the verge of toppling, then what will happen? All these points will lose contact. When you have applied that force at maximum height, it's just about to topple. Just. All these points have lost contact. So don't you see that the normal would be only from the extreme end over here? This is where the normal would be from. Think about it. Yes. Correct. Eric. Correct. Now these are the only forces acting on it. Now think about it. If I take this edge, all right, this edge, then when on the verge of toppling, when it is on the verge of toppling, think about it, all right. Can I say net torque about that edge is 0 because it has not yet toppled? It's not toppling yet, it's on the verge. Anything more, it will topple. So about this point, net torque is 0. Everybody agrees? Very good, very good. So now tell me, will normal and friction produce torque? And if so, which direction? About this edge, which direction will this normal and frictional force produce torque? Come on, answer in the chat box. Net. Yeah, very good. Come on, guys. What kind of torque will this normal and friction produce about the point of the edge? Yeah, Seshagri says no. Anti-clockwise says Krish. Aishwarya says positive. Guys, use your brains again. Think. Abhiram NVD says 0. Come on, Priyal says 0. Dora is wondering, is the torque, what kind of torque will friction and normal produce? Very good. It will not produce any torque. It will be 0 because normal and friction both are passing through that point. Think about it. No, Sumiran. Think about it. It's all passing through that point. Yes, Basanti. Correct. Very good. It's passing through that pivot, so the torque will be 0. So the torque by normal is 0. Torque by friction is also 0. This is by normal. Okay. This is by friction. Okay. Next. Will 3 mg produce torque? Will 3 mg produce torque about this point? And what kind of torque, clockwise or anti-clockwise? Think about it. 3 mg, what kind of torque will it produce about this edge, clockwise or anti-clockwise? They will ask the question, whatever it is, clockwise. Okay, so what will be the torque? This distance perpendicular, I hope you see that. This is nothing but the perpendicular distance, and what is it? Isn't it x? Okay, it might look as if it is passing through the center of mass. That is just by coincidence. I don't know, it could be up or below. I'm just saying, yeah, it will be x into 3 mg. X into 3 mg. This is by external force. This is by external force, x into 3 mg. Last thing, mg will produce what kind of torque about this point? What kind of torque will weight produce about this point? Think about it. What kind of torque will it produce? Yes, think about it. What kind of torque will mg produce about this point? Think about it, guys. Minions, come on, come on, come on, minions. Anti-clockwise, very good. What is this distance, guys? Because this is r perpendicular. This distance is r perpendicular. What is this distance? This is L. This is L by 2, right? L by 2 into mg, but this will be minus. So minus L by 2 into mg. Because this was clockwise, this was anti-clockwise. Be careful. That's why that minus sign, to show that it is opposite. Very good. This should be equal to 0, because the net torque should be 0 when it is on the verge of toppling. Now just rearrange it. So x into 3 mg will be L by 2 into mg. Now let's cancel out all the unnecessary terms. G gone, gone. That's it, I think. Okay, so x will be L by 2 3s are 6. L by 6. So that's it. This is the final answer. Understood? Understood? Yes, I will take it, Shreyas, after the March attempt, not now. Very good. L by 6. Isn't it simple? So a lot of people were saying it should be above the center of mass. That is wrong. Understanding this? Thank you, Chris, so much. Very good. So that is the answer. I hope you are getting to know how to solve questions now. Are you now ready to solve angular momentum questions? Are you guys tired? Are you guys tired? Should we do this? Yeah, when a tall guy will push the block, Vishal, then maybe it will topple. Are you guys ready to solve 1 or 2 more questions on angular momentum? Do you want to solve it? Yes? No? Very good. You're all hyped up. Are you loving this plain blackboard teaching? Guys, I did not come prepared today for today's class. Like, I was not at all prepared. I mean, just I came like this. The backend team gave me the questions and I was like, no, today I'm going to experiment something. Today I'm going to do something else. Today I'm going to give you a plain whiteboard kind of experience, and you will see how I create problems on the go. And by the way, this is how I teach in my regular batches also. Okay, chalo. Anyways, now going to the next one, let's do a question on angular momentum also. Let's do this. Thank you, Asta. Thank you, Dorabuji. Thank you, Manish. Very good, very good, very good, Gyalni. Excellent, Vishal. Loving the Josh. Very good, Roast Gamer. Guys, I hope you are liking the video. If you have not yet liked the video, please do it. And if you have not yet subscribed, please subscribe to our channel so to get more updates. Okay, so let's do this. Okay, so I have a question for you. Okay, now this one is, let's say, a disk, okay, of certain mass m1, I don't know how much it is, and certain radius r. This one, well, it's a hollow sphere of mass m2. I don't know whether it is more or less, and same radius r. Radius is same. Okay, great. Now what we do is we apply forces on it. So one force is here and one force is here. Okay, and both of them are hinged at the center. So they both are pivoted. So imagine one hollow sphere and disk, both are hinged at the center. They can rotate like this or like this, okay, at the center. That's the pivot. There are only 2 forces acting on it, and both the forces are F only. Both the forces are F. Okay. Now, let's say in the given question we have, okay, in the given question, if at t is equal to 0, both are at rest, and F acts, which is a constant force, till t is equal to t, sometime t. Then the question is, compare, alright, you have to compare the angular momentum at t is equal to t. Which one has more? So angular momentum of the disk blank angular momentum of the hollow sphere. Okay, so what are you going to put over here? More than, less than, or equal to? Very interesting question. Wow, my god, tape face. We have a plant also here. Very good. Yes, no minions, Nagpur fam. Today 11 o'clock, no lecture. Today is marathon. After marathon, I cannot talk much. Okay, Basanti says equal. Monkey says hollow. Okay, okay. I'm not sure which one will be more, which one will be less. The question is in front of you. Neha, ice cream party. Yes, even I am waiting for the ice cream party. Oh my god, why did you remind me of ice cream? Yeah. Okay, I'm going to eat ice cream after this lecture. Rishabh says equal. Okay, okay. Well. Let's see. Acha. Okay, I'll add some fun element in this. Let me add some fun element in this. The fun element is M2, let's say, is more than, or let's say M2 is less than M1. This is the fun element. M2 is less than M1, let's say. Let me add some fun element. Now it's going to be very interesting. There is going to be a big fight, cat fight between one team saying more than, one team saying less than, and another team saying equal to. It's going to be very interesting. All right. Come on, minions. Think. We have a cat fight going on now. Many people are saying hollow. Minions, Nagpur saying can't say also is coming up. Some are saying same. Wow, Krito's team saying depends. Pramesh, JEE result बाद में होगा. First concentrate on the lecture. Okay. So solve, Aishwarya, if you can't conclude without solving. So solve and tell. If you think you cannot say it so easily, if you want to write equations, come on. I'm giving you so much time. So many people are confused. That's why this problem is very important. These are conceptual problems which will make you from zero to hero. Okay. Okay, I'll tell you what. Use the definition. Acha, chalo, let's use the definition. Kya hai definition? Acha. Okay. If I compare the torques, the torque of the disk and the torque on the hollow sphere, tell me which one has more torque. Come on guys, which one has more torque? Let me know. Satyapriya, I have watched Telugu movies but does not mean I know Telugu. I can barely understand a little bit of Telugu. Tape face, what is wrong? Why are you saying 30 degrees Celsius? Everything fine? Tape face. Okay, both of them will be equal guys. R cross F, radius is same. Look at that. The radius R, alright, is R cross F. F is same, R is same. So in fact, both will be equal. Everybody understanding this? Yes, is that clear? Tape face, one more time you write that 30 degrees Celsius, I'll bring you down to 0 Kelvin now. Very good. Okay. Yes, thank you. Love you too, Shady Gamer. Thank you for all the love from Srinagar. Very good. Yeah. Now, think about it. If the torque is same, now isn't torque actually, think about it, torque is nothing but change in angular momentum upon time. Isn't torque change in angular momentum upon time? Isn't that clear? Torque is basically change in angular momentum upon time. Is torque same? Yes. Is the time same? Yes. I'll repeat. Is the torque same? Yes. Is the time for which the torque acting same? Yes, it's given from 0 to t, the constant force acts. If it is same, is the delta L same? Is delta L going to be same? Yes or no? Delta L for the disk will be delta L for the hollow sphere, guys. Everybody understanding it? Acha. Was their initial angular momentum same? What was their initial angular momentum? Both of them had the same angular momentum, 0. Didn't they have 0 angular momentum because both of them were at rest? It is clearly mentioned. So guys, what will be the final angular momentum if the change is same? I tell you, you both have 0 rupees and both of you get the same amount. What will be your final amount? Same, right? So won't the final angular momentum be also same? So shouldn't I put equal to over here? Shouldn't I put equal to over here? Oh my god, where is safe face? Has it gone to 0 Kelvin? Okay. Yes. Should be same. Trevor, now why did I do this question? Because I know why people get less marks in physics. Because you use your feeling wherever it is not necessary. You don't use your feeling where it is necessary. Wherever you have to visualize, you don't visualize. Wherever you have to go by mathematics, theorems, laws, logic, there you use feeling. Oh, hollow sphere. Oh, hollow sphere is big. Oh, it is empty, so it will have less angular momentum. Some weird logic you will use. So guys, that is something which you should not do, and that is what something you should learn. Understanding? So that is why I am telling you that please use mathematics, please use theorems, please use proper deductive steps which will make you arrive at a conclusion. Now, what has this got to do with anything? Will this matter? Will this matter? M2 less than M1 or M2 more than M1? Will this matter? Yes, I know, Rishabh. That's why I said that. No problem, Kirito. Yeah. So minions, Nagpur fam, that will not matter. Mass will not matter only. Yes, that's the whole point. Now you will see minions, Nagpur family, what I'm going to come to. Yeah, it will not matter. M2 less than M1. Now I have some Kida in mind. Let me add one more question for the same thing. And let me ask you, which one will have more omega? Omega for which one will be more? Hollow sphere or for the disk? More than, less than, or equal to? Come on, minions, let me know. Which one will have more omega? Think about it. Think about it. Which one will have more omega? Alrighty, alrighty, alrighty. Come on, minions. Do whatever you have to and let me know which one will have more angular momentum. Come on. Equal? Hollow? Acha, interesting. Can't say. Acha. Again, catfight has started. War has started. Come on, minions. Use your logic. Do not go by feeling. Go by logic. Acha, let me tell you what. Let me erase this first. Oops. Okay. Both of them had the same final angular momentum. What is the formula for angular momentum? I into omega, right? I into omega. All right. So moment of inertia of the disk into omega of the disk will be, by this logic, will be moment of inertia of the hollow sphere into omega of the hollow sphere. Okay. Now what is the formula for moment of inertia of a disk? It is mass r square by 2 into omega of the disk. Going completely by calculations. Mass, but this is mass 2, okay, into r square. Oh, but that is 2 by 3. So 2 divided by 3 into omega of hollow. Okay, now I don't need this anymore. I'll just remove it. Now think about it. R square will get cancelled and you will get omega of the disk upon omega of the hollow sphere will be equal to, be careful, you will have M2 on the top, M1 going downstairs, and that 2 and 2 will become 4 and nothing else, divided by 3. Now who is more, who is less? I think M2 is less than M1. M2 is less than M1. If numerator is less than this, but this is more than 1, how will this complete ratio be? It can be more than 1, it could be less than 1. I hope this is clear. Now this can be more than 1, less than 1, or even equal to 1. This is all doubtful because how much is the ratio of the mass is not given. Is that understood, guys? Everybody understanding this? Clear? Everybody clear about this? Understood? Yes, it would depend on the mass. Excellent. So the answer is question mark, basically can't say. You cannot write. So there will be 4 options: more, less, equal to, can't say. You will mark can't say. Yes, understood. So that's how you are supposed to solve problems on angular momentum. What a brilliant problem this was. Excellente. Excellente. Very good, very good, very good. Excellent, guys. Okay. Chalo, last question for today. Last question for today. Very good. Cool and clear. Kya baat hai, Snehal? All right, last question for today. Okay, so let's do this. Okay, now, okay, so, okay, say for example, okay. So again, you have a rod, okay, you have a rod like this, and this is the pivot point, okay, and let's say this rod has a mass of m and length L. Now, you are going to give it some impulse. Yes, you are going to give it some impulse somewhere, I don't know where. So somewhere you are going to give it an impulse. Oops. You're going to give it some impulse, and this impulse, oops, one sec, J, okay, this impulse J, I'll just write it down over here. Rod is given an impulse, I'll just put it more down. Rod is given an impulse such that, very important, the hinge doesn't encounter, the hinge does not encounter, okay, any normal reaction in the x direction. The normal reaction in the x direction is 0. The question is, all right, the question is actually to find this distance. Find x, basically, that's the question. So if this is x, the question is find x. So where will you apply the impulse? Question I started long time back, but it's okay. Okay, so where will you apply that impulse so that the hinge reaction is 0? Are you guys ready to solve this last question? Everybody, come on, minions, let me know. Yo, yes, energetic, yes sir, let me know if you're alive. Yeah, done, last question, ready to solve? Yo, put smileys, put hearts, whatever it is. Yeah, so that I also get some energy. Okay, very good, very good, very good. Now, okay, Krito, no, it's not so easy. Like I said, you should use feeling wherever it is required. Here you cannot do it by feeling. Let's do this. Very good, you guys are alive. Thank you, Vecha, for all the love. Thank you, Nancy, for the fire. Excellent. Hi, Saitaicha. Yes, Yalini on fire, Nancy on fire. Very good, very good. Gobi. Wow, we have Gobi also. Gobi paratha kahan hai? Okay, so let's do this. What are the different forces acting on this? Let's try to think about it. What are the different forces acting on the rod? Acha. Now, it is clearly mentioned that Nx is 0. There is no normal reaction in the x direction. Now, why will normal reaction come? Let's try to think about it. Okay, everybody hold a pen. Everybody try and hold a pen like this. Try and hold a pen like this. Okay. Now, if you push it, don't you feel that it is trying to move away from your finger? If you don't hold it properly, if you push it, won't it go like that? Yes or no? Glad Gobi is on fire. Yes. Don't worry, Satyapriya, it's okay. People will be hating us, but our love is more. Don't worry, it's okay. Yes, one day we will have so many likes, one day we will have so many subscribers, one day we will have so many views that these haters won't matter. Yes. Okay, so won't it just move away from you? So don't you see that there is some kind of reaction in the horizontal direction? Do you feel that? Yes. Don't you see that when you push that rod, give it some impulse, it will try to move away. So there is some kind of a normal reaction in the x direction. Now, if you carefully apply that force, if you carefully apply that impulse, then maybe it tries to rotate in such a way that this point on the top does not move only. I'll repeat. If you carefully apply the force somewhere, then maybe it moves ahead but also rotates such that the topmost point stays at rest. That means it will not have any tendency to move left or right. So there will be no reaction only on the top. Do you understand it? Yes, do you understand it? That's why there will be no normal reaction. Very good. Hello everyone. Welcome, join in. Now, if that much is clear, great. So let's try to draw the free body diagram. First, there will be a normal force in the y direction, and that's it. There will be an mg force in the downward direction. So mg will be in the downward direction. Great. Now what do? Once I apply that impulse, immediately after that, think about it, there will be an angular velocity. This is omega, which will be after the impulse is applied, it will get some angular velocity. Isn't that clear? Okay. Even the center of mass will have some velocity, this v. This is again after. Very good. Is that clear? Great. Now, if think about it, if torque is change in angular momentum upon time, isn't change in angular momentum torque into time? Isn't change in angular momentum torque into time? Acha. Now, this angular velocity which the rod has got, think about it, is because of the change in the angular momentum produced by the impulse. It is because of the change in the angular momentum produced by the impulse. Yes or no? Got it? Yes? Very good. So change in angular momentum is torque into time, and that angular momentum change has produced omega. So I can write this as final minus initial, and the torque into time. Acha, torque into time, can I say this torque produced by the impulse, right? Torque is R cross F. So can I say it is R is nothing but X into the force because of that impulse. Into delta T. Check this out. This is X into, X into the force into the time. R cross F. Is that clear? Everybody understanding it? Very good. Excellent, guys. This has to be taken slow because I want you to understand each and every step of it. Torque is R cross F. R is X. F is the force because of that impulse. Now think about it. Final angular momentum will be I, moment of inertia of the rod, into omega. What is initial angular momentum? Well, the rod was at rest. So won't it be 0? The rod was at rest, so it will be 0. Final angular momentum will be I into omega. I hope this is clear. Yes, thank you, Satya Priya. Thank you so much. Glad I have students like you. Okay, now what is the impulse into time? What is force into time? Impulsive force into time. What is the value called? It is itself called as impulse. Think about it. Force into time, isn't it itself called as impulse? Remember, impulse I or J was force into time. It was the effect of force. So can I just call it as J? Done? Okay, very good. Now, what is the moment of inertia of the rod? I just told you about the center, it is ml square by 12. About the center, it is ml square by 12. About the end, what is it? The moment of inertia of the rod, whatever you have to calculate, it is about the end. Please understand. This is the pivot point. So it will be ml square by 3. Yes, it will be ml square by 3, guys. ml square by 3, correct, into omega. It's going to be x into j. Everybody understanding it? Okay, ml square by 3, very good. Akhya, whichever part you did not understand, let me know. So I'll repeat what I just did. Torque is change in angular momentum upon time. Take time there. Delta L is torque into time. This torque is being produced by this impulse, not because of gravity, because gravity and this normal is it's passing through the pivot only. So the torque is R into F. R is X, F is force. But force into time is impulse. That's all I have done. And final minus initial angular momentum. Well, initial was 0 because it was at rest. Only after the impulse it rotated. Final will be I into omega. And what is I? ml square by 3. Okay, that's all I have done. Very good, very good, very good. Now think about it. Just rearrange. I don't know whether I need to rearrange. Oh, I don't know omega. Achha, I don't know omega. I need to get rid of this. Achha, I know what I can do. Omega is V by R. Isn't omega V by R? Think about it. Omega is actually V by R. Yes, I can use that. Omega and V are related to each other. Think about it. This velocity is actually omega into R. R is nothing but L by 2. Think about it. R is nothing but L by 2. So how about getting rid of this omega out here? So let's get rid of omega. So omega L square by 3 and omega, sorry, ml square by 3 over here. So omega will be nothing but 2V by 2V by L, I suppose. Omega is 2V by L, 2 into V divided by L. Yes, very good. This will be equal to X into J. This will be equal to X into J. Now just cancel out unwanted terms. L will get cancelled. Okay, very good. So I will get 2mlv, 2mlv divided by 3, and that J comes over here is equal to X. Okay. The question is to find X. I have almost got it, but I have also got one unknown, which is V. I don't want that V. I don't want that V. Think about it. I don't want that V. Yes, omega is 2 pi and B hota hai, but that is not needed, Akshaya Singh, over here. That will give us unnecessary things. We don't want that. Very good. So now think about it. How do I get rid of V? How do I get rid of V? Guys, use this fact. I'll tell you what. Okay, I'll just put it over here. Just use this fact. Impulse is nothing but change in momentum, correct? Impulse in the x direction is change in momentum. So just use this fact. What is final momentum? Well, that is mv. What is initial momentum? 0. So isn't j equal to mv minus 0? Everybody got it? Everybody got it? J is nothing but mv, correct. So v will be nothing but j divided by m. V is nothing but j divided by m. So let's use that over here and see what do we get. Yes, I'm just continuing it over here. So it will become 2ml by 3j. V is nothing but j divided by m is equal to x. Wow, so many things are going to get cancelled, guys. M gone, j also gone. So what am I going to get x as? X will be 2l divided by 3. That's it. That is the final answer. Why are we ignoring gravity? So minions Nagpur, gravity is not producing torque. That's why. Look at that. Torque by gravity will pass, or the force will pass through the pivot, so it will not produce any torque. Only impulse will produce torque. That's why we are ignoring gravity. Yes, very interesting question. Please watch all the questions, whatever I did today, very important questions, again and again. Watch it 10 times, watch it 2 times, watch it any number of times that you require, because I explained each and everything, every line in detail. So Richin, the whole idea is, see, there was a rod, I hit it. So there will be angular impulse and there will be linear impulse. The mass into velocity of that rod, all right, that is the final momentum, minus initial momentum will be the impulse. So whatever impulse I give will be final minus initial momentum. That is one thing. But there is also angular momentum change. That has been calculated by torque, and torque is Rf, and the rest other things are just substitution of formulas and solving the equations. That's all. That's all. That's how this has to be done. So watch it again and again, Richin. Okay? So just watch it again and again. You will get it. Don't worry. I have done everything in detail. All right. So do you want the PDF notes? Well, how do I get PDF notes? Let me save this somewhere. I'm not sure. Okay. I don't know. Maybe downloads. Okay. Okay. File name. Okay. Saved. Okay. At least I have it saved. And I think I can also export it as PDF. Okay. I'll export it as PDF. Okay. Okay. Exporting. Okay, fine guys, I will share all the PDFs to you on Telegram group. Okay, I'll share all that PDFs from the Telegram group. Is that okay? Yes, yes. I hope that's fine. Okay, now if you want this kind of teaching guys, which is going to happen in our regular batches, so please do not forget that we have 11th to 12th moving batches as well, which are going to start in a couple of weeks, and I'm going to be teaching over there. So if you want to learn under me in the regular classes and want to stay in touch, and you want to get doubts, you want to get test series, you want to get assignments, you want to get Tattva module, you want to get the option of learning in English or Hindi, all right, both kind of batches I'll be teaching in the English batch. So with regular test series and assignment, then you need to get into the pro subscription, where once you enter into the pro subscription, you can join under any teacher, you can get enrolled into as many courses as you like, and everything is free, like Amazon Prime or Netflix. You just pay for the subscription and that's it, you are in. Usually the prices in offline coaching and regular coaching, which you would have heard, any big names, they charge you anywhere between 1.5 lakh to 2 lakh rupees. But our pro subscription is less than 1/3 of that. So guys, yeah, and that too for 1 year with all kinds of exam preparation, be it CBSE, etc., be it Olympiads, everything at a very affordable rate of just 64,800 rupees. But if you use this coupon code today, then you will get 20% off, and that will be 51,848 for 1 year. That's very less. And by the way, there are financing options where you can pay this amount in installments also. So when you go to the payment page and when you try to pay, all right, you will get all kinds of options like financing or EMI option or part payment and all that. So if you feel that this amount is huge, you can do that. So my advice is join today, because the batches will start filling up. So if you want to get into the batch where all the amazing teachers are teaching really quickly, so please join as fast as possible. Yes, Nancy, there is an English crash course also. Crash course is there in 2 languages. Once you join, all right, you will be getting both the options eventually once you are enrolled. Yes. So Pratik, nobody knows when the result will come. So I'm not a person who can predict the future out here. Wow. Yes, Neha, I'm going to have the ice cream party now. And for those of you who are interested in the crash course details are also mentioned below for the JEE 21 aspirants. So go check it out, because it has 45 live sessions which can be replayed along with doubts and test series. And also, obviously, you are going to get the notes, you are going to get assignments and additional problems in the crash course. So if your aim is to crack April attempt, you should definitely get enrolled in the crash course. Usual price is 10,000, but 30% off on that when you use the coupon code SHCC. If you find any difficulty, please ping me on Instagram. I'll definitely help you out. Okay. Thank you guys very much. So Nancy, just call up the customer care, all right, and ask them that I want to get enrolled in the batch which is purely in English. So you will get that English batch separately, all right. So unless you mention that won't happen. So by default, you will get enrolled into the Hindi English batch. So you can just call up and get yourself shifted to only English batch. Okay, cool. Thank you guys very much. Thank you, Neha. Thank you, Nancy. Thank you. Very good. I made this original pun. In year 2030 Amazon advertisement. It's just like buying Vedantu Pro. Oh, that would be killer, Krito. I'm so I would be so happy when that happens. Yeah, cool. All right, bye bye Aishwarya, bye bye everyone. Thank you, Richin. Bye bye minions. Bye bye everyone. Take care. See you on Monday. All right, see you on Monday. Till then, have a happy weekend. Keep rocking, and yeah, any doubt, please follow me on Instagram. Ping me over there. I'll definitely answer your doubts. Take care. Chalo, tada.